There we go. We are live. Okay, awesome. By the way, folks, on Zoom, is the audio and video okay? All looking good? Let me know. And of course, folks on YouTube who are joining in, everything looks good. Okay, I see a bunch of thumbs ups. All right, awesome. Okay, a couple more minutes and then we can get started. How many of you folks have tried using Spring Framework 7 already? It was recently released. It's been just a few days, but I'm curious to know if you folks have kind of tried it out. Have you tried it out? Sad to see our hero turn on. It is sad, but I'm happy that you're calling me a hero. I don't know if I deserve to be called that, but I'll take it. Okay. Thank you all for joining from Berlin, from India, Uganda, Nigeria. Wow, all over the world. Thank you guys for joining. Antarctica. How's the weather there? Okay, I guess we can get started, right? What do you folks think? Let's get started. All right. So this is a workshop / course on the new features of the Spring framework, specifically resilience features. Spring Framework 7 was recently released and Spring Boot 4 has been recently released. So we're going to use both Spring Framework 7 and Spring Boot 4, and we are going to learn about a particular new set of features that has been released related to resilience, right? Resilience has usually been the scope of microservices, large distributed systems, and Spring Framework was always this bare bones stuff you need to build one application, right? In fact, when Spring Framework was created and introduced into the ecosystem, the most popular application development paradigm at the time was monoliths, right? We didn't have microservices back then. We had service-oriented architectures, which got a lot of bad press, and that's a whole different story. But most of what we were building at the time when Spring Framework was conceived of was monoliths. And most of the initial features that came into Spring Framework was geared towards building good monoliths, sustainable monoliths. But things have changed now. Things build microservices as well, distributed applications as well. And so that is also reflected in some of the new features that have come into Spring Framework 7, which is meant to support distributed application development. And we're going to cover 3 specific features of Spring Framework, technically 2, but we're going to dive into it. And these features are meant for handling resilience, for building applications with resilience. This is going to be a workshop and a concept deep dive. Okay, I'm not going to give you just the syntax. If you want the syntax, go ask ChatGPT. I'm going to tell you, I'm going to explain to you the concepts. I'm going to tell you why you need to use them, when you need to use them, what are the values you need to set up for these kind of things, what are the scenarios and all that stuff. And secondly, it's going to be hands-on, right? I have starter code for you to clone, and we are going to start working on it. We're going to have breaks where we're going to do hands-on. We're going to learn the concept, we're going to learn some of the syntax, and you're going to apply the syntax on starter code. I've kept the starter code as minimal as possible so that you don't have that, oh, like, you know, I have to study the code before I even start working on it. No, it's very simple. I'm going to explain to you what it is. And even the coding is very, very simple. The code that you're going to write in this workshop, you can actually get done in like a minute, okay, a minute, 2 minutes. But it's basically just to get you familiar with the new framework, kind of get that comfort that you can write the code and then you're able to successfully get it working, right? That's a good feeling to have, and I want you to leave this workshop with that feeling, and of course with the concepts that back it. All right, I'm going to start by posting the sample code that you need to be getting. So this is the code. I'm going to paste this in the chat as well. This is on my GitHub. It's called Spring. Well, it's unfortunate that I'm calling it Spring 1 Resilience App. Well, it's a Spring 7 Resilience App workshop. I'm going to paste this on Zoom and on YouTube as well. Just a second. All right. I'm hoping this goes to both places. Yeah, this is going to both places. So we're going to start out with concepts at the beginning. So there's still some time while you listen to me talk. Also clone this repo. And once you go to the repo, you have two folders, start and end. Start is what you're going to start writing code with. Okay, so you have workshop folder 1 and workshop folder 2. Right? Those are two different starting points. You're going to open workshop folder 1 in IntelliJ. This is a Maven project with Spring Boot 4 and Spring Framework 7 and Java 25 setup. We're going to use the latest version of Java because why not? We are learning, right? We use the latest version of Java. I sent out a note in the email to set up Java 25 on your machines. So make sure you have that. If not, you can just use SDKman and get it installed. Or use the latest version of IntelliJ IDEA and download the Java 25 SDK. That will work too, but you're going to be restricted only to IntelliJ IDEA. You can't run the Maven Spring run commands. So go ahead and set this up and open this in IntelliJ IDEA. This is going to be the starter code. All right, the start and Spring 7 Workshop 1. We're going to start with that, and then we're going to switch over to 2 as well. All right, I'm going to move this so that it can help my failing eyes. Okay. You are too big on screen. I don't know what that means. Am I too big? I can shrink myself a little bit. This is my standard setup. I don't know. Seems okay. I don't know. If you folks think I'm too big, let me know. Probably half the screen. Oh, okay. I see what you mean. Okay. I see what you mean. Let's see if I can shrink myself a little bit. I usually, the thing that I'm going for is a classroom environment, right? So let me show you. When I switch over to the slides, when I switch over to the slides, it'll be a little bit better. See? Now it's a little bit. Everything is relative, man. It's relative. It's that's the way it is. Anyway, okay. When I understand that when I'm showing the code, I'm probably going to make myself disappear. You don't have to see me when you're looking at the code. Well, I'll take that into consideration. All right. I can move around too. Yes, you're right. I can go here. I can go here. There's a certain point where there's a green screen behind me. There's a certain point where I get cut off. There you go. That point. But until then, I can move around, which is useful. Okay. I'm gonna make myself just a little bit. Okay, this much. All right. How about that? This is good. Okay. Let's get started. So start working on on cloning the sample code, putting it on your on your laptop or desktop or whatever, and then opening IntelliJ IDEA for the first folder, and then we can go from there. Right? So let's get started. Resilience in Spring applications. Like I said, we're going to start with the concepts. The concept of resilience, the key patterns of resilience, and From there, we're going to look at what are the new features of Spring Framework 7 that helps you implement some of those concepts. It's not comprehensive. We don't have like a full suite of resilience features that something like Resilience 4J gives us. But what they've done is they've looked at all of the resilience features and patterns that are implemented in the real world, and they've picked a couple of them and they've put them in the Spring Framework, so we'll understand what it is, right? We are going to establish a foundation. Over the next, maybe 15-20 minutes, we're going to establish a foundation that will carry you through everything that we're going to learn today, right? Because when you think about resilience, and if you think about the opposite of it, which is perhaps like a service outage, okay? So you're using an application, some outage happened, right? Something you expected to work started failing, Usually, we normally tend to think of it as one failure, right? Okay, you're trying to make a payment and the payment didn't go through. It's one failure. But often what happens in the ecosystems and the applications today is that it's usually a result of a cascading failures, right? When one thing doesn't work, right? One feature doesn't work in your application, it's usually a result of a cascade of failures happening, a series of failures happening. And that's what we're going to explore today. How do we design systems that don't fall apart when things go wrong? Not if things go wrong, because things always go wrong. How do you make sure it doesn't fall apart when things go wrong? So let me start with a question. What does it mean for backend services to be resilient? Okay, because usually when I ask this, people go, well, it's a backend system is resilient if it never fails. But that's not quite right? Resilience is the ability of a system to handle failures and disruptions gracefully. Okay, it's not about something will never fail. It's about when something fails, how do you handle it? And how do you continue to operate and recover quickly without affecting the overall performance or availability. Okay, it's not about without affecting anyone. When something fails, someone is going to get affected. But it's about how do we handle it gracefully and how do we handle it so that the overall system doesn't get affected, right? And again, notice the key phrase here. It is when failures occur, not if failures occur. This is a basic shift in mindset that we need to make when we're working with distributed systems. You can't say, I'm going to build a system which never fails. It's an impossible activity with distributed systems, right? It is going to fail. It's about how do you contain and minimize the impact and make sure that the overall system can work fine. I see some good answers over here. How to handle the failure and how many faults can something handle and how soon can it recover, right? These are all valid points. Let me increase this up a little bit. These are all valid ways to define what resilience is. It's about acknowledging that things do break, and when it breaks, how do you make sure that the overall system is not affected? In a distributed system, if you're dealing with multiple services communicating over the network, each of those services introduces points of failure where things can go wrong, right? There are a whole lot of failures that can happen. First of all, there could be network glitches. There could be timeouts. There could be application unavailability. You're probably calling some third-party API when that is down. There could be data center failovers, right? These aren't edge cases, right? These are normal things that can happen in a day-to-day running of an application. Why this matters more now than it used to is because of that shift that I talked about, right? Earlier, we used to create monoliths which would run on a single server. Now we have microservices that are distributed across multiple machines, possibly across multiple availability zones, and different geographical locations, different countries. You're calling third-party APIs that could be in a completely different set of geographies. So you're dealing with a whole lot of factors that you didn't have to deal with when you were dealing with a monolith, right? You're dealing with network latency issues, things that can spike up or down, which is completely outside your control. Things like these can happen, right? When things work perfectly, distributed systems are great. right? There's an example. There's a perfectly well plotted distributed system. Everything looks great. Things, work fine. But you notice each of those blocks are things that could potentially fail. And now what we have as a resilience, is my application working, is defined by the sum total of each of those individual apps working. And now the more blocks there are in your architecture diagram, the more things that can break, right? This is similar to Google's system design philosophy. Design to handle faults and failures, yes, absolutely. There's also the Netflix design philosophy of chaos monkey. I don't know if you folks have heard of this. Netflix intentionally breaks things in between. They just take a system and then they randomly break one block and see what happens. Okay, they've built to design, they kind of have this mindset to design so that even if things break, they can handle it, and they test it out by intentionally breaking it in production, which is crazy. All right, I'm going to talk about two distinct failure scenarios that you'll encounter constantly in distributed systems. And I'm going to tie these to the two new features that have been introduced in Spring Framework 7. These are not the only two things that can go wrong, right? There are so many things that can go wrong. That can be a whole class in itself. I can talk for a couple of hours about all the things that could break in a distributed system. That's not what we're talking about. We're talking about the key things that you should be aware of and how Spring Framework 7 introduces features to handle those specific things that are breaking. Okay? And those solutions are exactly what we'll be implementing in this workshop. Okay, two problems. What are the two problems? First, you probably face this many times when you're browsing online, you're using APIs or you're using applications. You do this all the time. You try something and something breaks or something doesn't work. What do you do? Let's say you're on a browser, right? You try something and the page doesn't load. What do? You hit refresh, right? You have this assumption of intermittent failures, right? Maybe it's a downstream API, maybe some other service which is like, there's a network connection issue, or maybe a third-party system. The call fails, or you get some kind of a timeout, or like a 503 or whatever, and the request just disappears, right? What do? You have to try it again, right? If you try the exact same request in these kind of scenarios where the failure is intermittent, if you try the exact same request, 2 seconds later, it would probably work, right? The failure was transient. It was momentary, like a network glitch is very common, right? Or a brief overload of a target service. Or maybe this happens more with containers. Container was just restarting, right? So the container needs some time to warm up. And when it was down, it gets a request for some reason. It's not configured. Load balancer isn't configured. Or maybe the health ping passed and then the actual thing failed because the application was starting up. Whatever. 2 seconds later, the same call will work fine. Okay? This happens all the time. And usually they resolve within seconds. But if you don't do anything, the default state is that the user sees an error and you as a user will have to click refresh. What if we could avoid that? What if we could click refresh instead of the user, right? That's retries. That's a retry logic. That's the problem that the retry logic solves. When an operation fails due to a transient issue, you retry again, right? It's very simple in concept. It's very simple in concept, but the implementation matters, right? You need to be smart about how you retry. You need to do appropriate delays, maximum attempt count. You need to have exponential backoff. Somebody mentioned exponential backoff here. Those things need to be there. Otherwise, we're going to get into a whole lot of other issues. There is a thundering herd problem, which is very, very fascinating. I'm going to explain to you when we get there. So you need to set the right kind of configuration and retry the right way. But at a fundamental level, intermittent issues, what's the obvious solution? Retry. Makes sense, right? Okay, that's the first problem. Retries are useful, but they only help if the failure is temporary, right? You have some confidence that when you try again, there is a better chance that it will work. You are optimistic. In these scenarios, retries make sense. But what if the problem is persistent? In this case, it's a little more dangerous, okay? Imagine things aren't down, but there is a slow dependency. Let's say you have a service, it's calling a downstream service, okay? Let's say recommendation engine, right? You need recommendation, so you call it and you want to wait for a response. Under normal conditions, let's say it responds in like 15 milliseconds. But today, something is wrong, okay? Some heavy load, or maybe there is a database contention or whatever. Instead of 50 milliseconds, the responses are taking like 10 seconds or 30 seconds, right? Or maybe they're not coming back at all, okay? So it's not a failure that you retry. If you get an immediate failure, what do? You retry again, but it's not a failure. It's taking longer, it's taking more time. Now what happens? You might go, well, yeah, the application might be slow, but it's still up, right? There's other problems that happen. Here's what happens. You have a service which is calling the recommendation engine, and you are making a request, waiting for a response. While it waits, your service is holding a thread, right? It's holding on to the thread. So there is a certain amount of threads in your thread pool. While you wait for a response, you are like, okay, I have to keep track of it because you need to know who to send the response back to. So you're waiting, and then one more request comes in. That's also taking long. It's waiting, and now your thread pool is getting crowded. Soon your thread pool is going to get exhausted and you cannot handle anymore, right? And for that person, the service is going to be down, okay? For these people, when someone makes a request and it gets into the thread pool, the application is technically up but slow. The person that makes a request after the thread pool is exhausted, the application is down, right? Here's an example. You have multiple requests, multiple services making a request to this one thing, and each time a request comes in, it's consuming a thread in the thread pool, and now the thread gets blocked and your thread pool starts filling up, okay? And they're not doing anything productive, they're just waiting. This is a problem. Virtual threads handle it, but there are other issues with virtual threads, and I will be covering that as well. But with the classical thread model, this is an issue, right? Threads get blocked. And so this is called thread starvation. Eventually, you run out of available threads, right? Now, your entire service is unresponsive. Not just for the requests that need the recommendation engine, because guess what? Now, let's say this is your thread pool in your application, right? They're all waiting for the recommendation engine. Now, someone makes another request that has got nothing to do with the recommendation engine, right? It just wants something else which is perfectly healthy, perfectly fine. But guess what? The service can't even handle it because the thread pool is full. The other service which could potentially answer that is free, completely able to handle it, but it can't even go here because the thread pool is taken, right? It's full. That is a problem. All right. I forgot to mute people, so I'm going to go ahead and mute. My apologies. Let's mute all. If you have a question, please post it in the chat or raise your hand and I will bring you up, right? But as a default, I'm going to mute because otherwise it goes into the recording. All right. Other dependent microservice will go slow? Yes. What is a virtual thread? I might cover that a little bit later. This is not a virtual thread workshop. I might cover a little bit of what that is later. Circuit breakers prevent cascading failures. Yes, this is exactly what circuit breakers were designed to handle. Is it kind of a DDoS? Yes, DDoS is meant to exploit this weakness, right? Distributed denial of service is basically distributed. People all over the world, wherever else, they deny service by basically making these requests and filling up this thread pool. Their goal is to fill up this thread pool or maybe make the application slow. One option is to fill up the thread pool. So now they filled it up. A legitimate user wants to access. They cannot. They have been denied service. That's distributed denial of service. All right? That's the problem. That is the problem. That's thread starvation. And the entire service becomes unresponsive even if the request that you're making has got nothing to do with the slow service. Even if something is very fast, you don't have the thread to handle it. You've essentially taken yourself offline because of one dependency, right? This gets worse, believe it or not, because guess what happens? Now you have your service. You have your service that's dependent on something else, and now this is slow, it doesn't have threads to handle it. Well, guess what? Maybe there is another service which is dependent on yours. And now guess what's happening? That service's thread is getting filled up because that doesn't have an ability to call this guy, right? Because this is slow because of this. So another thing that's calling this guy is going to be slow as well, right? The more threads get blocked, and then it just keeps getting further, cascading, right? This is called cascading failure, right? The problem cascades through your system. What started as one slow service has now taken down your entire platform. Now, what about retries? I talked about retries. When an issue is intermittent, you do a retry, right? It's obvious. You have a network issue, try again. Now, guess what happens when you do a retry with this kind of an issue? Let's take a look at this, all right? You tried something. This thread is sitting here. It's slow. So you go, okay, I'm going to try again. Guess what happens? Another request comes in. That also sits here. You wait for some time. Now, I'm going to try again. Another request comes in. So the retry actually makes this problem n times worse because it's filling the thread pool more than it should have. And it's basically making it worse. It's adding load to something that was already struggling. You're not helping it recover, right? You're actually piling on. You're actually making the problem worse. So retry is actually making things worse, which is all kinds of bad. What you need is a way to limit how many concurrent requests you're sending to that dependency. If you only allow, say, 10 threads to be waiting on the recommendation engine at any time, right? Even if it's completely unresponsive, you've only lost 10 threads, right? Imagine here if you were to say, okay, here's a recommendation engine which is sometimes slow. I just don't want to keep taking requests and wait for it. I'm going to allow 10 threads to go to the recommendation engine, max at any point of time. The 11th thread that comes in, I'm going to say, nope, I'm not doing anymore. It's already overloaded. You immediately get an error or something, right? It handles it somehow. With virtual threads, there is an alternative way to do this. But the idea is this service is consciously saying, I'm only going to allow 10 threads max. Anything beyond that, I'm not going to keep it in the thread pool, right? I'm only going to allow 10. So if the 11th request comes in, you can throw an error. You can say, no, too many requests. You got to wait. And then once something clears up and the request comes in, then you handle it, right? Now, again, I want to highlight the fact that this is not a good user experience for some people. Okay, imagine this. If we had unlimited threads, well, you can't have unlimited. Let's say you had 100 threads, right? And you didn't have this concurrency limit. The 11th request comes in, it sits in the thread pool. Maybe it's a little slow, but it eventually gets a response back. But with concurrency limiting, you're saying, I'm only going to allow 10. The 11th comes in, it gets an error, goes back. And then maybe it tries again, comes back when it is free, and then you handle it. You're basically pushing away requests when you know that you have hit a point where it's like, okay, I'm waiting. There are too many threads waiting for this guy. I don't want to have one more waiting. You're consciously turning back requests. And what happens here? For the requests that are being turned back, it's a bad experience, right? But think about this. We don't have that cascading failure anymore. Other requests that are going to other services, they're going to work fine. Other services which are dependent on this, they're going to work fine. It's never going to it's never going to bring the whole system down, is what I'm saying. Okay? That's the benefit of concurrency limiting. This is what concurrency limiting gives you. It's a form of protection, which says I will not let a certain dependency consume more than X of my resources, no matter how many requests are waiting for it. All right? The rest of the thread pool is still available to handle other work. This is called containing the blast radius, right? You have an explosion. It's where all the shrapnel goes to is the blast radius. This one is containing the blast radius. Even if something goes wrong, it is only going to bring it up to a certain point. There is an excellent question here. Then you can scale the service up. Yes, horizontal scaling is always an option, right? Whenever you have an issue like this, one thing you can do is horizontal scaling. So for example, that recommendation engine that was struggling, you realize, okay, maybe it needs more nodes, more instances. You scale it horizontally, the problem goes away. Very valid solution. But there are some issues where you cannot scale horizontally. In that case, you need to do this. And also, before you get to the point where you're horizontally scaling, you still need a way to make sure that this is contained. You can have concurrency limiting, and when you notice that enough requests are being turned away, you go, well, okay, we got to scale horizontally and then increase the limit. You know what I mean? Like it's a balance. This is basically a protection to make sure that things don't go from bad to worse. We need timeout. Timeout is another option. You can do timeout, but the problem is during the timeout, it is still consuming resources. So if you have enough requests coming in and you're still holding on to it for the duration of the timeout, you might still exhaust the thread pool for that duration, right? Let's say you have a timeout of 30 seconds. In that 30 seconds, if you get 400 requests, what are you going to do? It is going to consume all the resources, right? You're not going to turn back anything until the timeout period is over. So during that period, you're basically just adding more and consuming the thread pool. Won't that give a bad experience to the user? Yes, it will. That's the point. We want to limit the bad experience to only certain users so that the whole experience does not, the whole application does not go down and we give a bad experience to everyone, right? The point is, again, remember, containing the blast radius, minimizing the damage, not eliminating it. If we can eliminate it, great, but we are at a situation where we cannot. So we might as well have a bad experience to a few users than bring the whole application down and bring everything down to everyone. All right, I'm going to keep going. Please keep asking the questions. I'm probably going to tackle that during the break. This is a very interesting topic, and usually when I teach this, people have a lot of questions, and I love it. All right, now let's think through what happens with the concurrency limit. This is not the same as rate limiting. I see another question there. I'm tempted to answer these questions too. Rate limiting is very different, and I'll cover the difference between concurrency limiting and rate limiting when we talk about this in detail, with specifically with the Spring feature. All right, so what happens here is service A is receiving user requests, right? And service A is calling service B, which is the slow recommendation engine in our example, right? You implement a concurrency limit of, let's say, 10 on A's call to B. Okay, you have one service calling another service. You say when this particular service A is calling this particular service B, there's only going to be n number of concurrent requests. That's what this is. Understand? Now if B slows down, the first, let's say it's 10, right? The first 10 requests to A go through. Okay, so this is the incoming request. That's the incoming request. It's coming to the limit here, which is this guy. It's going to go through if it is within that limit. If it is not within that limit, it either waits or it errors out. Okay, now if it cannot get through, what happens over here? Aren't we still holding on to the queue? Aren't we still holding on to the threads? Well, it is still a problem, right? It's waiting for one of those 10 requests to be available. While it waits, it still holds on to that. Request 12 comes in, same thing, it's waiting for a permit, right? Requests keep coming in, it piles up. So what you've done here is you've protected service B from being overwhelmed. Okay, this is slow. So by adding a limit, you're making sure that this isn't being overwhelmed. But service A is now struggling because that's holding on to the threads, right? Now that has a problem. How do you handle that? Well, there are a few things that we did gain, right? First of all, we protected service B from overload because now we made sure that that doesn't get just constantly hammered, right? You might have hammered it with hundreds of concurrent requests without that limit. Secondly, what you have done here is you have created a decision point. The threads that are waiting for the permit, they don't have to wait forever. You can configure what happens when a permit isn't available, right? When you've exceeded the concurrency limit. What do? You wait with a timeout, that's an option. You can fail immediately, that's another option. Or you can queue up to a bounded limit. Now we can set another limit and say, I'm going to hold on to maybe 20 threads. And after that, I'm going to start letting go. I'm going to time out or whatever. You have the ability to configure it. Again, the goal is not to serve everybody. Something is wrong. Some people are going to have a bad experience. That's a given. The question is, what can you do to minimize it? And how can you make it less bad for the people for whom we are giving a bad experience? And thirdly, you can, well, timeout is another thing. With the, let me say that again. Thirdly, you can add a timeout on the permit acquisition. So over here, this can be with a timeout. It can wait for some time, and if it still doesn't get the permit, it just goes away, right? That's another option. So yes, you still hold on to threads when you have concurrency limit. This is something that people do get confused about, right? Concurrency limit is only to prevent it from going all the way through. But this guy's got a request. You have a limit and the limit isn't met. What's he going to do with it, right? He can't just throw it away. Well, the answer is yes, he or she can, or they can have a timeout, or they can put it in another queue. So there are options is what it is, right? It can fail fast or it can have a timeout. Those are all options that you can make. That's a decision point for you to make. And it gives you that decision point. All right, so fail fast with timeout, this is one option. Okay? It doesn't make the problem disappear. It gives you control over how the problem manifests, and you can decide instead of just uncontrolled thread exhaustion where everything fails unpredictably. That's your other option. So instead of doing that, you get controlled degradation, which is another very important concept with resilience. Controlled degradation. You are going to have a degraded experience. That was a question that was asked earlier. Well, for those users, it is going to be a bad experience, but you can do controlled degradation. You decide how many requests can wait, how long should they wait, what happens when the capacity is exceeded. You get to control it, and that's the key. Right? You're not preventing failures. You are choosing how to fail. A concurrency limit with a shard timeout, shard acquisition timeout means that some users get fast errors when the system is overloaded. Some users wait for the timeout and they get slightly slower errors. And for some people, it works completely. All right, that's the difference. Okay, let me see what the next slide is. See if I can handle questions. All right, that was a good time to handle questions. So let's take a look at the questions that have been asked. I love it. There are a lot of questions. I love it. Okay. All, if not most, dependency services need concurrency limits. Yes, I would say so. When you have a dependent service, this is the thing, right? There are a couple more patterns. There's the bulkhead pattern, there is the circuit breaker pattern. Those are things that you can add, and it kind of mitigates some of the concurrency limit needs, but it's a good thing to have, I would say, even with those patterns. There's a good implementation to have. Don't we have to scale vertically before horizontal scaling? No. The general industry practice is to try horizontal scaling first, and if that is not possible, only then try vertical scaling, because vertical scaling is more challenging, and vertical scaling doesn't scale. At some point, vertical scaling also stops. Horizontal scaling scales indefinitely. So it's recommended to do horizontal scaling more. If you horizontally scale without addressing the underlying problem, it might aggravate the issue with an underlying DB problem. Yes, that is true. So what this comment is addressing is that if, let's say, there is one more service down the line, okay, so you have a recommendation engine which is slow, and you go, well, okay, it's slow, I'm just going to add more nodes. Now, the problem with that is if the recommendation engine is talking to a DB, which cannot be horizontally scaled, and it has a limit, then just scaling this is going to solve the problem for the recommendation engine, but it transfers the problem to the database, because now all these new nodes that you horizontally scale, they're all going to start hammering the DB, and now the DB has a problem. How do you scale the DB? Well, you have to do vertical scaling there. So it kind of moves things along if you do horizontal scaling without trying to solve the underlying problem. That's a very good point. Is concurrency limiting the same as rate limiting? No, I will cover that in a bit. But short answer, concurrency limiting is how many requests are currently open at any given point of time, whereas rate limiting is how many requests have been open in a certain block of time. So rate limiting looks at the past X period of time, be it seconds or minutes or whatever. Concurrency limiting doesn't care what rate requests are coming in. All it cares about is at a certain snapshot, at a certain point of time, how many requests are currently open. That's the difference. If you horizontally scale, after some time, one by one, all instances are getting affected and the next instance get to scale up. Yes, up to a point. Again, you might hit certain blocks when you're accessing a third-party API, which they're like, yeah, we can only handle these many requests, and what are you going to do? Or a DB, which cannot technically be scaled, and so on. How do you get to the number of concurrent threads limit number? So that's not limiting when dependency is working as expected. It's through a bit of trial and error, a bit of experience, and you can make it a little smarter. It's an art, I would say. You know from experience, when you start building it, you can do a little bit of calculations as well. See the thread pool, how many threads you have available. You can look at the QPS and make a calculated assumption based on that, and then tweak as you go. Rate limiting is for DDoS type of attack. It's for a particular service limiting, and in limiting, I think your comment cut off there. I hope my answer about rate limiting versus concurrent limiting is clear. Even you can use the bulkhead pattern, but sometimes resources are not getting used at full potential. All right. Concurrency limiting for service B, which is slow, would help service A to keep serving requests as it is up. Well, it depends on what you're doing with that thing. If service A is holding on to the threads, waiting for service B's count to reduce, then service A is still affected. So that's the decision point I was talking about. You can choose to say, I'm just going to drop threads at a certain point, so you don't wait forever. What does permit in 500 milliseconds mean? Permit is basically what you are allowed access to the service. When you say concurrency limit of 10 requests get the permit to go. The 11th one does not get the permit and it has to wait. Right? That's the permit I'm talking about. How does one make these configuration decisions? Based on the performance, yeah, I kind of addressed that in the other question. So based on the performance, the QPS, how many requests do you anticipate coming in? What is the thread pool configuration across the stack? So you can do the math, right? You can calculate, okay, I'm getting 10 requests per second, and this is the number of threads, this is the average response time. You can calculate how long something is going to wait, and you're going to exhaust the thread pool or not. All right. Is creating fixed thread pool is concurrency limiting? In a way, because by creating a fixed thread pool, you are limiting in a way, but you're doing it in a bad way, because you're basically breaking the experience across the chain. It's not just breaking this one. New requests are going to fail, and it's going to cause this cascading failure. So it's concurrency limiting by doing cascading failure as a side effect, which you don't want to do. Virtual threads, now is not the time, I'm sorry. I'm going to have to come back to that afterwards. Can I ask you folks a favor? If you have a question, ask me a question with a Q colon in the front so that I know it's a question and not a comment. I see I'm reading some comments as well, and I want to make sure I address the questions first. So if you have a question that you need me to answer, ask with a Q colon. Thank you. All right, I think I've addressed most of the questions. I'm going to move on. Resilience pattern landscape. I see one more question, so let me address that before I move on. In reactive Spring applications, how can we relate as they have event loops instead of thread pool setup? Well, this does work with reactive applications as well, and it's more of virtual threads. With reactive and virtual threads, you don't have the risk of running out of threads on one server, but you still prevent the request going in and affecting the destination service, and that's why you would do this. And I will cover that in the subsequent section when we talk about that. In case the problem gets transferred to the underlying DB layer or the root cause is with the DB layer itself, then how do we handle it instantly? If it's the DB layer, the problem gets bigger, right? Yes. If you anticipate a consistent problem with the DB layer, then yes, it is an issue, and you have to scale the DB layer somehow, right? Either through vertical scaling or have multiple instances and do read replicas. Scaling the DB is a problem. This is all a way to figure out what to do while you get to the scaling process, right? If it's intermittent or as an early sign before you actually get to scaling, how do you make sure that the whole system doesn't break down? That's what this is for. If you see this consistently and you set a concurrency limit and then you see the limit being hit all the time, you don't just rest, right? This is just to make sure that the whole system doesn't go down. If you keep hitting the limit all the time, that's a sign that you got to fix something, right? This is just there to protect your system from going down till you end up fixing the issue. All right, let's move on. Now, we looked at a couple of core problems and a couple of solutions, right? One is transient failures, for which retries are a good solution. And we looked at resource exhaustion from slow dependencies, right? Now, I'm going to give you a broader view of the resilience patterns. And I think this context is important because in real world production systems, you will often use these multiple patterns together, okay? You're not going to just implement these two because they're in Spring Framework 7 and you're going to ignore the others. Of course, you're going to use the others as well. So I want to introduce you to those concepts, but it is just in a conceptual level. These two are going to be code. We're going to write code to implement them, all right? We looked at retry, handles transient failures by automatically attempting an operation again, right? And again, you got to be smart about this with exponential backoffs and setting maximum attempts. And there's also the concept of jitter, which is very interesting, and I will explain what that is as well. You got to set those parameters when you retry. Concurrency limiting. This is sometimes referred to as throttling or semaphore isolation. You hear these names as well. Basically, that's what they're referring to. They're basically saying one service to other service, don't make more than 10 requests at a time, right? Hold on to it. That's really what this is. They're all fancy names for that. It's basically how many concurrent requests can be made for a particular operation when you're calling a particular service, right? It protects your thread pool from being consumed by a single slow dependency. And then you have other patterns for resilience, right? You have the timeout pattern. It sets a maximum duration for an operation. You cannot wait forever for something that may never return, right? So timeouts work along with concurrency limits. Even if you're limiting concurrent requests, you still don't want to wait indefinitely, right? You say, okay, you got in, I allowed 10 requests, you were the 9th request you got in, but still, you don't get to wait forever. You have a timeout. And if you don't finish within the timeout, I'm kicking you out and letting someone in. Fixed number of seats, right? You got to be optimal about it. Next is a circuit breaker pattern, right? This is another popular pattern. It takes this protection one step further. It monitors for failures, and when the failures exceed a certain threshold, it stops making calls entirely for a certain period, right? This is called failing fast, and you see that happen in a lot of places. It gets its name from the electric circuit breakers that we have in our houses, right? When a voltage exceeds a certain point, it's an indicator of something going wrong. It's an indicator of perhaps a short circuit. So you want to stop that right away. So that's what a circuit breaker does. When a voltage exceeds a certain point, it just breaks the circuit. So there's no electricity flowing in the circuit. Okay, that's what a circuit breaker pattern does. It checks if the number of failures are exceeding a certain point, it just stops making calls. No more requests. Even if the thread pool is all clear, even if there's no timeout, no whatever, up to a certain period of time, it's going to wait. And after that period of time passes, then it starts sending requests again. This is another useful pattern. It's kind of, it starts off like there's a little bit of messiness going around. It usually solves those problems, right? It gives it a pause, and systems usually, like depending on how you've designed it, it usually fixes itself and then takes a breather and then starts sending again, and things are going to be fine. It often works out well. It often solves problems where you don't even know what happened, just the circuit breaker, and then it continues again, things work fine. It's like, yeah, okay, we don't have to worry about it anymore, right? So it has a cooldown period, and then there are smarter ways to do circuit breakers. After a cooldown period, some patterns, they send a test request to see, okay, has the service recovered? If it has, then it starts sending gradually. There's a circuit breaker pattern. And then there's the bulkhead isolation. Bulkhead isolation, it partitions resources so that the problem, if a problem happens, it is affecting only one area and it doesn't affect another, right? A very good example for this is having separate thread pools for different dependencies, right? Service A is calling service B. It has one thread pool for B and another thread pool for a different service. So if B is slow and it consumes threads, well, only the B's thread pool is filled. Service C is being called, that thread pool is free, C is responding fine, so those requests go through. So it's isolated the issue to one particular thread pool, right? So if one pool gets exhausted, it's fine, the others keep working, right? This is the bulkhead pattern. In this workshop, we're going to focus on retry and concurrency limiting, right? Because these are the two patterns that Spring Framework 7 has decided to provide full first-class support for, right? And they do it through simple annotations, right? Circuit breaker is very valuable, bulkhead is very valuable, but they require additional libraries. And a good library that I can recommend is Resilience4j, right? And there are a couple more as well. Resilience4j is something that I've seen many people use. So we'll acknowledge that all those patterns are useful, and you would obviously use that in a production system, but our hands-on work today centers on what Spring gives us out of the box. All right? I want to, before we get into the code, I want to highlight, this has come up a couple of times as well. This is not free, right? Both retry and concurrency limiting come with some costs, right? You need to understand the trade-offs, and that's usually what you do when you do system design, when you do architectures, right? You always have trade-offs. You have to understand what it is and be willing to make it. You need to understand that the bad is much better. Experiencing the bad sometimes is much better than the worst situation if you didn't take the trade-off, right? You're choosing that. Right, so what are the trade-offs for retries? Retries adds latency to any operation, right? Your first attempt takes 100 milliseconds, next takes another 100 milliseconds. If it succeeds, then great, you take 200 milliseconds, and then if it doesn't succeed, you have backoff, exponential backoffs. It takes much longer, and you might end up still failing. If it works, great, you might say, well, it's better to take longer and succeed rather than fail immediately. But it might not always be the case, and sometimes you might make the users wait for long and then end up failing anyway, right? The second problem is that it only works for certain types of requests. Okay, let's say you're making a payment, and the payment you made a payment, you charged the user's card, but then the request came back with some weird error. Are you going to retry? I don't know. Did the payment go through and the response come back bad, or did the payment not go? Well, I cannot afford to retry in certain cases, right? It's only available for, this as an option is only available for non-idempotent operations. If it's idempotent, then no, you don't want to risk it. What are the trade-offs for concurrency limiting? It does not eliminate the thread exhaustion problem, right? It relocates it. And now we have to deal with, okay, what do I do when something fails, right? Now you have the threads that cannot acquire permits, they still need to go somewhere, right? They can either wait, which can consume the thread pool, or they can fail fast, which returns an error to the user, or you can queue them up, which has its own memory and latency implications, right? And you're also potentially rejecting traffic that could succeed, right? So let's say the failure is conditional, right? You say concurrency limit of 10. The 11th one could have potentially worked if you didn't have the concurrency limit. Maybe it is looking for something else and the response is quick, and or maybe it was cached and it could have returned, but you are rejecting it because of the concept that you don't only want to allow 10, you don't want to risk another one sitting and consuming threads in the thread pool, right? That's another risk. And then you have the throughput versus safety balance, right? You want to balance for throughput, but you also want to balance for safety and tolerance for errors. It's again a trade-off there that you have to make. So it's again all about balance. I'm gonna say that and wrap up this session. For the concept part, we're going to take a break and then we're going to continue the coding part. All right, so this is you're designing for failure. Okay, so now we're going to get into these individual features, right? There are two complementary layers here. One is the protection piece, which is the concurrency part, and the recovery piece, which is the retry part, right? I kind of think of it as the optimistic part and the pessimistic part, or the defensive part. Retry is optimistic. When you're retrying, you're optimistic that this time it's going to work better. If you aren't optimistic, there's no point in retrying, right? So your retry is with an optimistic nature that, okay, this was a small temporary issue and a transient failure, and this time it is going to work better. With concurrency limiting, it's more defensive, right? It's basically for like longer running issues. Okay, you feel like this is an issue that can go on for longer. You want to be defensive about it. So these two kind of approach it in two different ways, and they work out well. So recovery layer, retry is optimistic, and concurrency limiting is defensive. And they work together. You have quick blips and prolonged slowdowns. They work together. All right, so this is what we're going to cover in the workshop. We're going to handle transient failures in retry logic, and we're going to do thread and resource blocking risks, and we're going to do concurrency throttling, and we're going to have, I think I have an exercise where I combine both. I don't remember. If not, then we can forget about the combination thing. At least I'll cover it. I'll touch upon it. We might not have an exercise where we merge both of them. All right. We're not going to cover circuit breakers. We're not going to cover message queue resilience and chaos engineering and reactive programming. I'll tell you how it works with reactive programming, but we're not going to cover reactive. We're going to look at the traditional model, which most people use. I don't think a lot of people use reactive programming. Then again, the goal is to understand, not just the syntax. Now, we're going to take a break, and while we have the break, I want you to reflect about this. I want you to think about your own systems, the things that you're working on on the job, and things that you're writing code for, and look at the two problems that we've discussed. Okay, what are your transient failures? Do you have intermittent failures? If so, how do you resolve it today? Right? How do your system handle it? And how do users see it and perceive it? Ask yourself this question in the break. And then for slow dependencies, what happens if your dependency becomes slower, right? And something that takes around milliseconds, what happens if it becomes seconds? Do the threads wait indefinitely in your architecture? What happens? And how many threads block? Do you know where you have deployed your microservices, how many threads they consume, right? Would your application survive if one service goes down? Okay, not rhetorical questions, right? Think about your actual services that you have deployed and see what happens when something were to go down. Will you share these slides? Yes, I will share the slides later. They're just markdown slides. This is the styling is all through CSS, but yes, I will share the markdown slides on GitHub, the same repository. All right, so now we'll take a break for like what, 10 minutes, 15 minutes? What do you folks think? Put a number in the chat. 10, 15, and 5 minutes. No, 5 minutes is not an option. All right, 10 or 15. I see a bunch of 10s. Okay, so let's do 10 minutes. And while you do that, ask yourself these questions and look at the code, and we'll take a look at this together, and we'll go from there. Right? A 10-minute break. Right, welcome back. Welcome back. Let me switch over to section 2. Okay. Did you folks get the code? Any trouble getting it from GitHub? Any questions about that? Please let me know. YouTube, yes, the Java Brains channel, and yes, you can rewind. You should be able to rewind on YouTube. And of course, I will be uploading this on the channel for free after a while. In AWS State Machine, if a Lambda fails, we will retry after some interval. In Java, how do we achieve this resilience? That's exactly what we're going to cover in this section, implementing retry logic. See? Just hold on to that thought. How to categorize or identify if a failure can fail under recovery layer or protection layer. Well, again, it's the concept. I talked about two things, right? One is temporary versus more long running. Temporary and intermittent, you do a retry, right? And if it is long running, then you guard against it. You can't solve it, you guard against it. And it's also the optimistic versus defensive. When you're doing a retry, when you're optimistic that the problem is going to get solved, you do a retry. If you are a little pessimistic and you want to defend against it, that's when you set a concurrency limit. I think concurrency limit is more of like you have like a limit, like a threshold that you know it's not going to exceed. Retry is like just you can just throw it in there if you know that there is it's a temporary issue you want to guard against for. Free for all or members only. Free is for all. I wouldn't consider members only content as free. Is it possible to increase the volume a bit? Is it a problem? Listen, I don't want to ignore what you're saying, but this is a question that I get asked often, and I usually have mixed responses to it. Right? This is the volume that I've said I have never touched it. And usually there's someone who says raise the volume and someone who says no, the volume is, it literally just happened now, right? The volume is good for some people and not for some. So I would say try adjusting the volume at your end, because this is like, I have maximum set right now. I often thought there was something wrong with my setup, but it's like, it's at maximum. And when I usually edit these sessions, I see the volume is good. So I have a feeling it might be at your end, so maybe try it out. Try increasing the volume. All right. Let us switch over. I'm going to move this a little because I see this part is getting cut off. Okay, there we go. There we go. Okay. Implementing retry logic. I'm going to start talking about this and hopefully it'll answer some of your questions. If not, we can get back to this afterwards. We're going to start with the code, right? In section 1, retry volume at your end. Yeah, this is not intermittent. This is more long running. So I don't know if a retry is the right pattern for it. The volume is low. It's low. It's going to be low for a while. Okay. We talked about why resilience matters, right? Now let's see a real problem in action. And I'm going to show you the code and we will run through what the current situation is. This is going to be a starting point for us to implement these features and write the code. Again, remember, the code itself is very simple. It's the concept, the understanding behind it, which is what I want you to take away from, right? You're literally going to be sticking annotations in there. But the question is, why are you putting the annotation there? How much value you need to configure for it. Those are like, what are the properties? What are the knobs and dials? That's the key, right? Again, remember, if you need the syntax, You don't need to come to me anymore. You would have had to come to me in 2010, but not anymore. You have ChatGPT for it. You come to me for the understanding. I'd like to believe that even in 2010, people would come to me for the understanding, but it's a different issue. All right, now I'm going to switch to IntelliJ, and I have the starting point for the code here. This is the starting point for the code. You folks can see me? Not see me, see the code. I see that my green screen is cut off here. Let me fix this. Yeah, that's where the green screen ends, and I had to trim this a little bit. I still see a little bit here. Man, sometimes I wish I had an assistant. Okay, is the font okay, or do you want me to increase it? I said to bring my son. Yeah, he has to be a little older, unfortunately. Not yet. Okay, let's see if I can increase the font a little bit. Let me know what you folks think. Is this font okay? Okay, cool. All right, so go get the code, set it up on IntelliJ, and you should be able to see this. Okay, you should be able to see this. This is a Spring Boot project. Okay, if you look at the pom.xml, you will see that this is a Spring Boot 4 project. Okay, it is using Java 25, and it has very minimal dependencies. Okay, you can't see the top. All right, let's see if I can fix that. I see what you mean. It's picking only this part. I'll see if I can fix that. Give me a second. I do have it. Why is it not picking it up? There we go. Thank you for calling that out. Okay, there we go. Cool. Okay, so this is pom.xml with Spring Boot 4. Okay, this is the newest version of Spring Boot. We are picking all the new stuff here. You see this? We are using Spring Boot Starter version 4.0, which is very recently released, and we are using Spring Framework 7, which is also recently released, and it is using Java 25. So first, make sure you have Java 25 on your system, and you have it configured, or you have the SDK on in IntelliJ. I'm going to paste the link again for the folks in the chat. This is the one. Clone the repo and get it. Thank you. Thank you for posting. I'm just going to post this here anyway, just in case. All right. So this is the Spring Boot app. One thing that I realize is again, my poor vision. I'm getting old. I need to hunch down to see what I'm doing here. Okay, so this is typical Spring Framework project, and I'm going to do this in this view because a lot of people are comfortable with this. This is a Spring Boot main application, and it has one controller and one service. Okay, it's simulating a payment service. So you have the controller here, which is called the payment controller. There is a API called /pay. Right? You pass in the order ID and an amount, and it will make a payment to that particular order. Typical payment API, right? And it is making a request to this service. Now this is the process payment service. Now this is simulating an intermittent failure, right? I'm basically failing this service 50% of the time, right? It's basically a coin toss. Half the time it fails and the other half it succeeds. I'm simulating it by using the Boolean. That's it. It's very simple, very simple code, right? And I'm of course doing validation over here. Is like I want the amount to be more than 0. If not, I error out. So there are 2 exceptions. In the exceptions, one is the payment network exception. The other is payment validation exception. So it throws those 2 exceptions. All right, that's it. Now I can run this application by just hitting this play button, or you can use the Maven target if you want. Have the application open. Now I can go to the controller and run the controller. You can either do curl or you can send requests this way. Okay, so here is, let me get rid of this. So this is basically pulled in a couple of, not this one, this is, well, that happens later, right? Here is the request, right? It's making a call to /pay with a particular order ID and a particular amount. It is randomly generated. You can basically set it. If you want to do a curl, you can do that too. Curl of this URL, localhost 8080/pay, order ID, give it whatever alphanumeric value you want, and just the amount. It can be any amount you want, right? I'm going to hit run, and here you see I get an internal server error. Okay, and then I'm going to hit run again, and this time it worked, right? It works 50% of the time. That's the point. So this is simulating a intermittent failure, right? It's not going to be, if you have a service that fails 50% of the time, they have different problems to worry about. This is just to kind of exaggerate it so that we can see how our solution works. All right, this is the problem. We have a controller that's calling a service which fails intermittently. Now, how do you implement the resilience features in Spring to do a retry? Right? This is a perfect candidate for a retry. Right? This is an intermittent failure. If only you would try again, it would work. Of course, one way to do the retry is to put it in a loop and manage it yourself, but we're smarter. We will use the Spring framework way, the new Spring features that have come up. Okay. So we have a couple of ways in which you can run the demo. Go ahead and give it a try. So you can either run it on IntelliJ, or you can use this, right? You can use the Spring Boot Maven command Spring Boot run. If you're using the Maven command, make sure that your Maven has Java 25, like you have Java home set up, because Maven uses the Java home variable, and run it. And then you can use curl, right? Use a curl with that URL. You're basically going to get, you should be able to, it should roughly fail half of the time, right? It's simulating an intermittent network issue. Try it a few times, and you can see that inconsistency. How do you call the service from IntelliJ? So the IntelliJ has this this HTTP request feature, which you can use, but that is only for the Ultimate Edition. If you have the Community Edition, you don't get this feature. So with this Ultimate Edition, anytime you have a Spring controller, you can click this, and it'll bring you to this HTTP file, request HTTP file, and you can just click run here. Or you can do curl, which is what I was talking about here. You can literally run this. You don't need IntelliJ for this at all, right? You can run this in the command line, and you have the Spring Boot application running, and then you can use this curl command, and you will you'll be able to see that response come in. All right. Thank you for pasting the command in the chat. That's really helpful. All right. I can paste this as well. So these are the two. Copy. Interesting, it doesn't copy. Well, you're gonna have to type this out then. That's literally menw Spring Boot :run. If you're Spring Boot developers, you should be comfortable with that command. And curl is basically making that request with a specific order ID and amount. Go ahead and give it a try, and then we can continue. If folks have got it working, say a thumbs up or yes or something in the chat so that I know you have it working. If I see enough, then I can keep going. Okay, I see a bunch of thumbs ups. Awesome, awesome. Let's keep going. So in our demo, we have intermittent failures happening 50% of the time. Again, it's not what you would typically have, but network connections, timeouts, intermittent failures. Where's the chat except YouTube? We also have a Zoom happening. If you had registered on my website, you get Zoom. Both are free, but there's a Zoom thing as well. So this was pasted on Zoom. I'm trying to copy, but it doesn't work, and I'm too lazy to type it out. So if anyone on YouTube wants to type out the commands, please do. So yeah, we have it on Zoom as well. Okay, so we have the 50% failure rate, which is not ideal, but it works in productions. In production scenarios, you might see like 1% or 5% requests failing due to transient issues. But even a small percentage adds up when you're processing thousands of requests. And you have to remember, it is for each service. We have a microservice architecture where there's a service calling another service. Each one of them is like even 0.5%. That's a significant issue, right? You want to implement retry for handling these kind of issues. So here's a simple solution for solving this problem is to just try again, right? Just try again. And you put this in a loop, which is what I talked about. Put it in a loop to have a certain number of retries and try again. Because if a human saw this error, what would they do? They would click the refresh button again, right? So basically we want to automate that behavior. So that is provided in Spring Framework 7. There is an annotation, because guess how Spring solves any problem? They create an annotation. So there is an annotation called @retryable, right? This is Spring Framework 7's answer to this. So Spring Framework 7 includes built-in retry support through this retryable annotation. So what do you need to do to make something retryable? You have a method and you want the consumers of that method to retry. If it fails, well, you stick a retryable on top of it. This is how it works. Okay, you add a retryable. So this is a payment service and this is the logic. You want this to be retryable. You put a retryable on it. That's about it, right? You save and you restart. It will not work, but this is how you annotate the method, right? So go ahead and give it a try. Put a @retryable on it. And if you're using IntelliJ, it should give you the import suggestion as well. I don't remember the import here, but it's in like it's Spring Framework 7 is in the system path, so it should pull it up. So what you're doing here is I want you to understand the intent here. You're basically saying, I want this method to be, it is retryable. You can potentially retry it. Okay, that's literally what retryable means as the language, right? This can be retried, right? FYI, if this doesn't work, feel free to retry. That's what you're saying here, right? That doesn't work because there's one more annotation that you need to put, which is called enable resilient methods, right? The @retryable annotation by itself does not do anything. You need to tell Spring to process these annotations, and that requires putting this on our configuration class. You can either put it on a config class or you can put it in the main application class. You stick those two and you're going to have a method that is retryable. Spring is going to go, okay, this didn't work first time, right? It says it's retryable, so let's try it again. It's going to automatically retry it, right? So add these two while we talk about this, right? So this is what enables retry support. So you're going to be adding two annotations to that project. First is the retryable annotation on the method that fails intermittently, because that is retryable. Second, you stick this enable resilient methods annotation on the either a configuration or the application class itself. Okay, the enable resilient methods is an annotation that supports both the retryable and the concurrency limit. It supports both. So stick those two, restart the server, and you should be able to see it is going to be retried. I'm going to switch over to IntelliJ and I will show you what that looks like. I guess I need to shrink myself even further for the code. You don't need to see me when you're looking at the code. All right, how about that? Okay, IntelliJ. I'm going to switch to the end part. Okay, I see thumbs up happening. So you folks are able to get it to work. That's awesome. That's awesome. Okay, so this is what it looks like. This is the end piece. I have a bunch of configuration items here. Just ignore that. You just stick a retryable here, and then we have the application itself having the enable resilient methods. We're going to look at those properties a little bit, right? A little bit. Now, if you run this, you will see it will always work. Oops, no, I have to restart. Give me a second. I'm going to have to stop the other guy and start this one. All right, I'm going to start this. And now if I run this, it will always work. It might be a little slow. You see this? It's taking its time. It's taking its time because it might have hit the error twice because it's 50-50, right? I'm guessing it probably hit this error multiple times. Let's take a look. You see that? It failed twice and then it worked the third time. Okay, so it failed twice and it worked the third time. So that's why it took a while, but it still did it, right? This is the retryable. You're basically saying, I want something to be retried. It is safe to retry. When Spring knows that it is safe to retry, it will automatically retry. Okay, now how does Spring do it? What is actually happening behind the scenes? What does this enable resilient methods do? Well, behind the scenes, there is actually a bean post processor, right? There is Spring registers a retry annotation bean post processor that wraps the logic in AOP proxies. That's how Spring does a lot of this magic. It's AOP proxies. You folks know about how transactional works, right? There's a transactional annotation. Basically say, if you stick a transactional on top of a method, Spring is going to start the transaction before the method executes, and then it's going to end the transaction, commit to rollback after the method completes, right? This is very similar. It's basically wrapping this method. Once you stick a retryable on a method, Spring wraps it in a proxy. You don't know it. You think you're calling the method, but you're actually calling the proxy. And the proxy says, I'm going to try. If I get an exception, I'm going to try again. Get another exception, I'm going to try again. How many times? I'll talk about that in a bit, but basically you're having it retry. So it is creating a proxy, and the proxy is what is doing the work of retrying. You're not doing it, right? You're just calling it once. You're calling the proxy does the retries until there are no exceptions, and then it returns back a response. And how much it calls when it gives up. What if we keep getting an exception? Well, there is a certain configuration that you can set for that as well, right? But It's the proxy that does it. The key thing about this is that this is Spring proxy calls only. Okay, now if I were to take that method and create a new instance of it, of the class, and then call it directly, it is not going to work, as you can imagine, right? So if I go to this here, and this is my service, right? I have an @retrieval here. This is the process payment service. If I were to create a new payment service, get a new instance, and then call process payment on it, I'm not going to get a retry. Okay, if I get an exception, it's going to throw an exception. It's just a Java method that throws an exception. Of course, it's going to throw to the caller, right? That's the way Java works. What Spring is doing is using AOP so that it intercepts it. So in order to leverage Spring AOP, you have to use it through the Spring container, through the Spring infrastructure. It's only then that it works. So Spring proxy calls only. So maybe there is another service that's calling this, or a component or a controller, right? Some Spring entity is calling this, so it goes through that, right? That's the reason why we had to start the main method and then call through the controller. If you just create a simple Java class or a main method that calls this method directly, it's not going to work, right? In this example here, I have another method which calls this directly. It's not going to call the retry because it's not going through Spring, right? Even though I see a question here, I think this is what it's addressing. If you have a service method calling another method in the same class, it'll not work. Yeah, it'll not work. So here, this is actually a service. Payment service is a service. It is a Spring service, and you have another method here which is calling this thing here. It's not going through Spring. It's not going to get the retry, right? There's a question about the parameters. I'm going to cover the parameters now. So it's the same limitation as transactional, right? The call has to come from outside of the bean for the proxy to intercept it, right? It's the same thing with transactional. It's the same thing with cacheable. All those other Spring, features which work using this intercept model. All right, we went through the demo. Now, if you drew this, it works, and you can see the requests. And I added, log messages. You can go to the end project as well if you like, and you can see that I have log messages which says how many times it is being retried. All right, there's a default behavior for this retry annotation. Okay, first, just put @retrieval. I saw, you saw I had a bunch of attributes in the demo code, but if you didn't have any of those attributes, right, by default, it is going to do 3 retry attempts. If you just stick an @retrieval there, it's intelligent defaults. That's what Spring does all the time, right? There are some intelligent defaults. You don't have to specify any values besides just say @retrieval. 3 retry attempts after the initial failure by default. Okay, if the third time it retries, it doesn't work, it gives up. Okay, 1 second delay between attempts. That was the reason why it took a while, right? It took a while for us to see the result. There is a 1 second delay. And there was a question asked, when does it retry? Of course, it retries on an exception. If the method returns a value, Spring doesn't know if it is an error or if it is a valid value. So if it returns a value, it says it's worked. But if it throws an exception, that's when it says, okay, something is not right, and it will retry till either the retry attempts are exhausted or an exception is not thrown and the method actually returns. Is that clear? The key point here to remember is that it retries on any exception. And this point will come back to bite us, and I will cover that in a little bit. But basically, that's the idea. Any exception, by default, you just stick a retry without any configuration. Any exception, it just retries, and it does 3 times with 1 second delay in between. And then even after that, if you get an exception, it just returns the exception, throws the exception back to the caller. But if you get a value of any of those attempts, it just returns that value. You can customize this behavior though. You can put values, attributes to this retriable annotation. You see here there is a max retries. Okay, I can change it to like, okay, retry 5 times or retry 10 times. You can configure this. There are a whole lot of properties that you can use to configure. And we'll go through those properties now. First is max retries. This is how many times you want the retry to happen. Right? This excludes the initial. When you say max retry is 3, the initial one failed, which is fine. It's how many times it's actually retrying. Right? That's the key thing to remember. How many times is the retry happening? The first call is not a retry. That's the initial invocation. The second time it's the retry, right? How many times the retry happens is what you configure here with max retries. Delay is how long it waits before it tries again. Right? The default is 1 second. You can configure it to however long you want. You want it to wait for 2 seconds, you can do that. And the more delay you add, the more latency you add to the result, right? But you also have to make sure that if something is broken, then you're not going to be able to immediately retry. I lost my train of thought there. I'm sorry. Yeah, if something's broken, you don't want to immediately retry. You want to wait for a while and then try. So you can configure the delay accordingly. And then the multiplier is exponential backoff factor that I'm going to address in a bit. I see a question that's coming in. Let me address that. This seems to be a common question. What if the thing is being called by the controller? What if this thing is called by controller? See, it depends on how it gets the instance. How does Spring AOP work? Spring AOP works by creating an instance wrapper, right? It's using inheritance. So when you do dependency injection, Spring inserts an instance which looks like the bean that you're inserting, but it is actually a wrapper proxy. That's how it does it, right? So when a method is calling another method, you shouldn't think about where the method is. You need to think about what instance it's calling it on. Okay, let's take the other method, right? If it's using dependency injection, it gets a bean with a dependency injected, and then it's calling a method on the dependency injected bean. Guess what? It's calling a method on the proxy. But if it's doing new and then calling a method on the new instance that you created, well, it's not a proxy anymore. It is your instance. It is not going to get the benefit of Spring. Okay, this is Spring 101. I want you folks to really understand this. This is basic of Spring. The only way Spring does its magic is through wrapper classes that are injected. As long as you say, hey, Spring, inject this for me, that's the opportunity for Spring to wrap this up in a proxy. Okay, if you're doing a new, Spring does not have a say in it. You're directly calling the instance. No retry, no transaction, no cacheable. Does that make sense? It's very important to remember. So it doesn't matter where the method is. What matters is what's the instance on which you're calling the method. I really hope that makes sense. This is very, very important. What's today's topic really? A great question. Today's topic is resilience in Spring Framework 7. Spring Framework 7 and Spring Boot has been recently released. There are some resilience features that are being built in. This is a workshop where we learn about resilience patterns, learn about it in an architectural concept, and try and apply those features in a brand new Spring Boot 4 Spring Framework 7 project. Okay, is there anything we can do to detect that the call was made to retriable annotation method outside of Spring Proxy to help troubleshoot? This is hard to detect. I'm not sure I understand. If the call was made to retriable annotated method outside of the Spring Proxy, Spring cannot help you with that by definition. What you're asking is there a way to detect a direct invocation that didn't go through the Spring proxy? Well, if it didn't go through the Spring proxy, Spring really cannot help you with it. You're going to have to find out a way to handle it directly. Like you can't use Actuator for tracking those kind of things. So I think static code analysis would help in that case. You can literally look at what are all the invocations of that code in your code base and find that out. I think that's an easier problem to solve, I think. Or I'm misunderstanding your question, I don't know. Is there a fallback annotation as well to handle the situation where all retries are exhausted? Great question. There is, but not in Spring Framework 7, right? Resilience for J has it. There is a recover annotation which allows you to recover, and you need to annotate it on a method which has the exact same signature as the one that you're retrying, right? You put a retryable, there is an, I don't remember what the equivalent for it in Resilience for J. There is a retryable equivalent for Resilience for J. That's how Spring got its idea. It's copied, inspired by Resilience for J. So you can retry with Resilience for J, and if the retry fails, there is a recover annotation that you can put on a method with the exact same signature, and the library is going to call that and return back. So that's a fallback mechanism. But Spring Framework 7 does not have it. It retries, and if it continues to get the exception, it throws the exception back. It does not have a recover or a fallback. All right, I covered that. I'm sorry, Himansh. I don't mean to ignore your LinkedIn invite. I will avoid this. I promise you. I will take after this workshop. I'll look at the pending invitations and I'll accept. I accept everybody. I'd love to connect with everyone. So it's not specific to you. It's just that I haven't done it in a while. I promise I'll do that after the workshop. Okay. Okay. So fallback method I covered. Spring Framework, resilience mechanism, broad scope. In Spring 7, these resilience mechanism are broad scope, application scope. I don't understand. I don't understand the question. It's scope is for that particular method. Okay, so you enable resilience methods for the entire application so that Spring creates those AOP proxies to do retries, but that's about it. It's for whatever annotations, whatever methods you annotate. Which exception will be sent back if different exception with multiple retries? The last one. The last one. Yes, this is another possibility, right? You say, I want to retry thrice, and each time you retry, you get a different exception. Well, it's the last one after all the exceptions are, all the retries are exhausted. It says, this is the last retry. I'm going to see what it gets back. If it returns, great. If not, whatever exception is thrown, it just sends it back to the caller. Spring does not store the exceptions. No, it just retries and it changes the behavior on the last retry. When it is doing the last retry that it's configured to, it does something differently, right? It does not wait. It just basically acts as a normal invocation. The last retry acts as a normal invocation. So whatever exception is thrown, it gets sent back. All right, let's keep going. Now, here is a problem with this approach, right? I'm going to show you what the problem is. Now, I'm going to go to IntelliJ, and here is the retry. Works great, right? Here's my retry code. I'm going to change the amount to, I don't know, -10. What happens now? This is invalid, right? So what does the service do? The service has validation, and it says validation failed, and it throws payment validation exception. Guess what happens now? What does Spring do? It says, I got an exception, I must retry. So it retries with amount -10. Guess what happens? Throws back the exception again. So the point is, there are certain exceptions which you don't want to do retry for. For this particular thing, I don't want retry. Doesn't make sense. So we want to selectively retry for certain exceptions, not always. You can't blindly retry for all exceptions. Okay, you can give it a try and you will see that it basically does a retry. Well, let's try it. It's going to do a retry and it fails multiple times, and it is going to because I have the includes and excludes. If I didn't have that, it would retry. If I didn't have this, it would keep retrying, and it would eventually fail after a long time. While it keeps retrying. It says, oh, there's an exception, I'm going to try again, I'm going to try again, and then finally it returns the exception back because it realizes, oops, it's not going to work, right? So this is a problem, and we want to selectively retry and not retry all the time, which is what those include and exclude properties do. Okay, we don't want to waste time and resources retrying something which we know will never succeed. All right, so retrying non-transient errors are a bad idea, right? By default, at retryable, retries for any exception, but not all exceptions are transient. We looked at two exception types there. One is the network exception, which is transient, a network hiccup, and a retry might help. And then there is a payment validation exception, which is not transient. Bad data, it just won't fix itself, right? It's bad data, it has to go back. So you need to tell Spring which exceptions are worth retrying. And that's what the includes property does. Includes property takes in the exceptions that you should retry for, right? If it's basically saying, hey, go ahead and retry if what exception you get back is included in this list, either matching the types or the subclasses. It checks for subclasses also. If it matches a subclass, even then it'll be retry. Everything else will fail immediately. There is an alternative, which is the excludes. You basically say, I want to exclude this. If this exception comes in, don't retry. If anything else comes in, you can retry. So you have two properties. You can use includes when you have a specific list of retryable exceptions, and you do excludes when most exceptions should be retried except for a few. In this case, I would probably do excludes and say, this is a payment validation exception. When that fails, I don't want you to retry. And it depends on the logic, depends on what you've got going on in your code. You can either choose includes or excludes. So let's take a couple of minutes, go ahead and try out these properties on the retryable annotation on your code. And you can also try out the max retries property to kind of configure how many retries happen. You can set it to 5 and see it retry 5 times. So go try it out. Should be very, very quick. So here with these values, with the includes, so I have both here. I have includes and excludes. So I'm going to restart. And now when the data is bad, I get the error right away. And when the data is good, there is a network exception, then it does retry. You see, it's retrying and then it gets back the result. So this is the ideal situation. We want this. Okay, if you folks have any trouble with this, let me know. I have a question here. I would love to ask you folks, what do you think? Some people prefer books over video courses. What do you folks think? I think in my order of preference, it is this kind of classroom environment is top for learning. Nothing beats that. No book beats that, okay? A teacher teaching you in class, this kind of an environment is number one. And number two is, I would say, tied between books and videos. It depends on what you're trying to do. For conceptual things, I think video would still help because it's an explanation. But for syntax related stuff, like I want to understand how to do something, just syntax, write the code, then books or maybe even like documentation on a website would be really useful because I can just copy paste it. So I think it depends on what you're trying to learn. Cool. Yeah, I think a lot of people agree with me. Cool. Thank you for writing that. Good question. Okay, let's keep going. If you folks have any trouble with this, please let me know. But this should be very simple. Just one annotation should be simple. It's about understanding the concept behind why you do this, when it works, when it doesn't work. That's what I want you to take away. All right. So here is kind of, I would say, a production-ready configuration. You can of course tweak this depending on what you need. But basically, what I have is a max retries of 3. I have a delay of 1 second, so I wanted to wait for 1 second. For network retries, 1 second is usually good, but for other situations like database latency, you might want to tweak it based on how much you need. And then the multiplier, I'll cover multiplier in a bit. It's what you do exponential backoff. But the idea is that with a multiplier, each retry takes longer. So basically, when you have a multiplier of 2, the first retry takes 1 second, the second retry takes 2 seconds, the third retry takes 4 seconds. Every time the retry gets multiplied by the multiplier, right? The duration gets multiplied by the multiplier. Okay, this is one configuration. You can set this up. If you're using Spring Framework 7, you can literally just stick this annotation and you get retry automatically, right? You don't have to bring in any library, nothing of that sort. It's covered in Spring, which is pretty handy. You can configure different values for different methods. Now let's dive deeper into what happens during a retry execution. I hope this is clear. I don't know if I can zoom this up a bit. This should be visible, right? Let me know if it isn't visible. So basically, there are multiple steps that happen here. First of all, like I said, Spring intercepts the call through an AOP proxy. There's an AOP proxy that intercepts it. When you're calling a service, you're not calling the service directly. You're calling a method on a proxy, and that proxy does something and eventually calls your service. So the proxy executes the method and it catches an exception. When the exception matches what you have in your includes, or it does not have what you have in your excludes, then the proxy checks if the retries are exhausted. Are there any remaining retries or not? If there are remaining retries, then it waits according to the backoff policy. Okay, how long do I have to wait? That's the delay times the multiplier. It waits and then it invokes the method again, and it keeps doing this until either the method succeeds, in which case it returns the results, or the retries are exhausted, in which case the last exception is thrown, right? Remember, on the last retry, the invocation is any regular invocation. There's nothing that happens. On the last retry, it's whatever you normally expect to happen is what happens. Everything else is controlled by all these factors. Does that make sense? The actual retry logic lives in the Spring's retry template. And there's also a retry policy, which I'm going to talk about, right? This annotation is just a convenient way for you to configure this without writing all the boilerplate code. Now, the key advantage of this is that the retry logic is completely separate from your business logic. Your process payment method does not need to know that it is being retried. It just throws exceptions when things fail, right? The framework handles the retry mechanism, which is what you want. You want to decouple it. You don't want the method itself to be aware of it being potentially retried. The method is like, when an error happens, I'm going to throw the exception. I don't care. The retry happens outside. This allows us to kind of evolve the method separately, while your retry implementation and the retry factors evolve separately, right? The framework handles it. That's the division of concerns, which works well. What exactly is jitter? I'm going to cover that in a bit. Is there a way to group all the logs specific to one retry in order to trace this through? That's the tracing thing, which is a little out of scope for this. I'm not going to cover. You have the same log implementation and all the tracing implementation that you normally do, but that's available. The retry is just what gets invoked. When it gets invoked, all the normal tracing infrastructure applies. So nothing changes there. What is jitter? I'm going to cover that. Is this new in Spring? Yes, Retry is new in Spring Framework 7 and as a result in Spring Boot 4. We didn't have this before. Before, if you needed to do this, you had to bring in resilience for J. Is it better to have handled retry at a service or a gateway? The gateway level is a different type of a retry. This is at a method level. Okay, you're not even looking at a controller level. You're looking at a method level and saying this particular method needs to be retried. Because think about it, right? You have your controller. Gateway and URLs are basically at a controller or invocation level. You have your controller that is calling this method, right? This controller is calling the method. This controller could be calling something else. It could be calling 3 different business methods. One method does a retry 3 times, another method does no retry, another method does a retry 10 times. So you can configure it at a method level, which is super useful. That's what this gives you. If you're talking about gateway and network, like that's a different kind of retry. You might want to do that separately, but this one's at a method level, which brings in a completely different set of tools. It's very powerful in that way. All right, moving on. Retry works with reactive support as well, right? Reactive methods also can benefit from retry. I'm going to quickly go through this because reactive isn't so popular, especially with, virtual threads coming into the picture. So I'm just going to quickly go over it. So it's they've made the annotation work seamlessly, whether you're using the classical thread model or the reactive model, right? You use the same annotation, and if your method is returning a mono or a flux using the reactive paradigms, it detects the reactive return type and it applies the retry logic using the corresponding retry in the reactive sense. So there is a mono retry, there is a flux retry. So it uses the right spec and makes sure that the right retry happens. So you don't have to worry about it. You just stick an annotation on top. It works exactly the same way. Okay, it's just using with reactive. It's just using it's decorating the reactive pipeline with the retry operations with the reactive way. With the normal way, it's probably using some kind of an imperative code logic. With the reactive way, it's using the retry operators. But all you need to know is that it works exactly the same way. The benefit about the retries with the reactive approach is that they're non-blocking, right? That's the benefit of reactive, right? When something is waiting, it doesn't block. So when you're doing retry on a reactive counterpart and it has to wait for a certain delay, that wait time is not blocking the thread pool. Like it's not consuming a thread. It just goes off. It's the thread sleeps during the in the blocking case, the thread sleeps during the delay. With reactive, the delay is scheduled on the reactor scheduler, and your thread is released to do other work, right? The retry logic is non-blocking, right? Because reactive was designed to handle this high concurrency kind of a scenario with a small number of threads. If you're blocking with reactive, it doesn't make any sense. It would defeat the purpose. So Spring handles it correctly for you. That's all I'm going to say for reactive, and I'm going to move on. If you folks have questions, drop a comment offline, async, in the video thread or wherever else you can reach me, and I might make a video about it. But that's all I have to say about reactive for this. The idea is the same. The retry is the same. All right, now let's talk about exponential backoff. I'm going to address the problem, which is the thundering herd problem. Okay, so let's suppose that you add a constant 1 second delay between retries, right? Now, let's say all retries have a constant 1 second delay, right? Your code fails, waits for 1 second, and then it retries, and then fails again, wait for 1 more second, it does a retry, right? Seems simple, but think about what happens. If a service is overwhelmed, let's say it needs time to recover, you call, waits for 1 second, and then this call calls again while new calls are happening. So the next second there are more calls, and then that fails, waits for 1 second. The original batch, the second batch, and the new batch, they all call together and then wait for 1 second. You see, it's like it's gradually accumulating requests. There's more and more every second, every iteration, there's more and more stuff, and it's basically just hammering it. Every second, there's a bunch of calls that go in, they all fail, and then wait, and next second, more calls go in, and then it just keeps happening. Okay? Imagine like 1,000 clients doing this. The service gradually starts to recover. In a second, now we get 1,000 calls, the thundering herd, and the service gets overwhelmed again, and it goes down, waits for a few seconds, gradually comes back up. Guess what happens? In a second, again the thundering herd, again it goes down. So this repeats, and the service, it might try its best, but it never gets a chance to recover because this is happening. So in order to address this, there are two things you need to consider with the retries. One is exponential backoff, and the second is jitter. Right? Both these factors help solve this problem of like just the herd thundering together. We want to avoid that. So you avoid that by doing these two. Exponential backoff is a way to increase the delay with each retry attempt, and jitter is about changing the precise time at which the request happens. Both of them work together. So let's start with exponential backoff. So the formula is the initial delay plus the multiplier times attempt number. Right? We saw there is a multiplier attribute in the retry annotation. We can say multiplier is 2. Now if the initial delay is 1 second, then it is going to do the next attempt is going to be initial delay. So it's like 1 second and the multiplier is 2. The first time it is going to be 1 second delay. The second time it's going to be 2 seconds delay. The third time it's going to be 4 seconds delay. Exponential, right? Multiplier, exponent, attempt number. Exponentially, it's going to get slower and slower. So it makes sure that once it recovers, yes, of course, this person is going to have to wait a little longer, but it doesn't constantly hammer it. It gradually spaces out, right? So kind of give it more time to recover. So at any point of time, you know, the current delay gets, every new attempt takes longer and longer exponentially. And you can configure what the multiplier is. So here is an example. So we have first attempt at 1 second, second at 2, third at 4, and fourth at 8. At some point you're going to give up. Since it's growing exponentially, it becomes unreasonable very soon. So you're going to have to cut it off at some point. But for 4 attempts, this is a fair way of configuring it, right? Since the delays go exponentially, the downstream service gets progressively more time to recover with each attempt, and you have a better chance of it working in the third attempt, giving it 4 plus 2 plus 1 rather than just hammering it 4 times every second. Okay. I'm going to skip this. I tried doing a diagram, but it didn't work out, so we're going to skip it. You can cap the maximum delay because, again, at a certain point, because it's growing exponentially, it becomes unreasonable. So you have a max delay value, and you can say, this is the maximum delay that I'm going to wait. Cap at 30 seconds. Beyond that, it's not going to work, right? By the way, cap not in the Gen Z language. Cap as in the old traditional way. They talked about me getting old. Cap as in the limit, okay? Not the other meaning of cap. Next is jitter. Jitter is another way you can solve the thundering herd problem, right? Exponential backoff does help, right? You still have a problem of, let's say, 1,000 clients coming in. All those 1,000 have the same exponential backoff, right? So let's say 1,000 hit the first time, 1 second. Now you wait for, multiplier should always be greater than 1. Yes, that's a good point. Thank you. 1,000 requests come in, go back, wait for 1 second. 1,000 requests go in with the additional requests. Again, wait for the original 1,000, again are held back, wait for 2 seconds, all those 1,000 go in, right? Now, even though you're kind of spacing it apart, the batch itself is going together, right? All those thousands are going together which is bad because even if it is spaced apart, when those 1,000 requests come in, it does tend to overwhelm the server, right? It's all retrying at the exact same time. This causes the thundering herd problem to still persist because everyone's retry schedule is synchronized, right? Jitter is a way for you to add a little bit of randomness to break that synchronization. Okay, so for example, you know that the delay, you have to wait for 1 second. Well, how about this? Randomly add a few milliseconds difference here and there, right? Either do a few milliseconds early or a few milliseconds late so that they don't exactly go at that 1 second mark. That is jitter. It adds a little bit of randomness to break that synchronization. So here is jitter, okay? Just random variation. So you say 250, right? For 250 milliseconds of random variation. So basically it's going to do random number generation of 0 to 250, and it is either going to do minus of that or plus of that. Okay, so let's say it randomly generates 100 milliseconds. So it is going to do, I'm going to send a request 100 milliseconds early or 100 milliseconds late. So that's jitter, right? It kind of breaks that that kind of coordinated access. So this is the jitter effect, right? It's going to be the base delay. It's going to find the base delay based on the exponential configuration, and then it's going to do plus or minus random of 0 to jitter, which is what I talked about. For 250, random of 0 to 250 gets a value, and then it's either going to do plus or minus. So either way, you're going to get plus, so minus 250 to plus 250, some random number, it is going to affect the delay. So it's going to do a little bit earlier or a little bit later so that it's close. You don't want jitter to be like 1 second because that would basically you're getting to the delay level. Little bit of variance here and there so that it's not all coordinated and synchronized. Okay, so how much jitter you should add is usually about 10 to 25% of your base delay. Okay, if you add too little jitter, it doesn't spread out effectively, right? The retries aren't spread out effectively. And if you add too much jitter, it creates unpredictable timing. It makes debugging difficult. Like, okay, is the delay because of the main delay or is it because of the jitter? You don't want the jitter to be a significant component because it becomes unpredictable, right? So usually it's like 10 to 20% of your original delay. And Spring says like you got to use in milliseconds, so that's kind of gives you that precise control. All right, here's a real world example. We have a 1,000 second delay, multiplier of 2, and a jitter of 100. So the first attempt, it fails, T0. Second attempt, 1.05, right? It waits for 1 second with a jitter of 50 milliseconds, and then it fails. And then the second, it waits for 2 seconds, and now it's a little less jitter, like what, 80 milliseconds. And then the third jitter. You get the idea, right? So this is how it works with the jitter, right? It's a little off here and there, but more or less it goes with the same retry delay and order, an exponential delay. Now, when all the retries are exhausted, that's when we do exception handling. All right? Retries are just that, retries. They don't guarantee success. After exhausting all the retries, well, if you still have a failure, Spring throws the exception back to the caller, right? And that exception propagates up the service layer to your controller layer, or maybe it goes back to the user. It depends on how you handle it. Okay, and you can handle it at the controller layer using all the normal Spring mechanisms, right? You can have exception handler, you can have controller advise at a global level, and you can handle it just the way you normally used to. That part doesn't change, right? Just want you to kind of separate that out. When the last retry happens, it is just like it's a normal invocation. All right. How do I know the delay times number of attempts I have to retry? Well, you don't have to know that. Spring keeps track of that for you. And you can calculate what the delay is based on what the retry number is. All right. let's take I don't know if I should take, okay, let's continue further. Let's proceed this and then we'll take a break. Programmatic retry. Are you folks able to hear the knocking sound that's coming in? Somebody's knocking over here. Are you folks able to hear it in the audio? Let me know. You're able to hear it. All right, give me just a second. I'm gonna try and address that real quick. I'll be right back. All right, I am back. How long is this workshop? I had originally planned it for 4 hours. And let's see where we are. We are 2.5 hours in. So for 4 hours, half a day. I don't know if I'll be able to cover it all the way. One thing, and you folks who have attended my workshop know that this is a teach till I drop kind of a thing. Most often I manage to get through, but sometimes it's like I get tired and like I can't proceed further. I just say, let's call it a day, right? Not a hard limit, but we'll try as much to get as much value as we can. Okay, so let's talk about programmatic retries. So far, we've looked at the retry. Has everyone tried the annotations and everything looks good? Any questions or any comments? You're able to see the retry happening? The failed method, it's like it's literally failing half the time, but the caller just calls and it works fine. It just retries and it works fine. Okay, I see a question here. Can we write like with the logs with the failed attempt 1 out of 3 retrying in 1 second? You can log the failed attempt by managing the state yourself, but the how many times it retries also you're gonna have to manage. Like you're gonna have to manage it yourself. I don't think there's a Spring way of doing it. Let me show you how I'm doing it. In my code, you see here, I have, get rid of this. So I have this thing here, which is the counter, right? See, I have an atomic integer, attempt counter, right? Every time a retry happens, like every time a method is called, I do an increment and get. So I have the attempt. And then you see here, I'm logging it. Attempt number, attempt processing payment, right? You can technically do this. You don't need a listener. You just have an item in the state. You want to take that out and, kind of like abstract it out and keep it somewhere else, you can. But this was a simple way for me to do it, to keep track of the count. You can also keep track of the delay by doing the calculation yourself. You have the values here. So you can technically do it. It's not going to be as elegant. I don't think there is a Spring way to do it. If you folks know anything, let me know. I might have not come across it, but that's how you can do it. You can kind of keep track of it that way. Okay, so we've had @retribal, which works great, seamlessly. But what if you need more control? What kind of control would you need? First of all, let's look at some limitations of the retry annotation. Firstly, it is at a method level only, right? Retryable works on method declarations, right? You want to retry a whole method, you have to put that on there. What if you want to retry an arbitrary block of code inside a method? right? You want to just retry this one thing a bunch of times. You can't put an annotation in a single line of code, right? You're going to have to create a method out of it and then use the Spring way to call it and all that. That's, yeah, move it to a service and inject. Yes, you can do that, but again, it's a little bit of an overhead. What if you need like one-off things and you don't want to create a separate service for it and deal with all the hassle of creating that, injecting that, creating a member variable in the caller side? That becomes painful, right? Secondly, this is a static configuration. When you put an annotation on the process payment method, you're basically saying whoever calls process payment, they're going to retry the exact same amount of time, have the exact same number of retries, the exact same amount of jitter. It is at the method level, right? It's the same setting for every call. You might want to configure it. So for example, let's say there is a high value order. You want to do more retries, right? There's a $10 order. Okay, let's do 3 retries. Let's say the order is for, I don't know, like $100,000. You don't want to give up so easy, right? You want to try it a few more times and see if it works. High orders, depending on what is being executed, you might want to do different retries, right? Different customers might have different SLAs, right? Different time of the day, different at peak hours, you might want to do shorter timeouts. At different times, you want to do longer timeouts. And for other endpoints, API endpoints, you might have different backoff strategies. So these are dependent on, not on what is being called, but on who is calling it and what are the parameters that are being passed to it, right? This doesn't allow it. It's just static configuration. Annotations are configured at compile time, so it cannot adapt to runtime context. So the solution, there is a programmatic way of doing retries, and that is called retry template. Right? You folks are aware of the template concept in Spring, right? You have transaction template, for example. It's basically a class which you can pass in a lambda, or like you can pass an inner class and say execute it within that, and then the template handles it. Right? You don't need the AOP proxy. You basically have this wrapper class called the template. It uses the same retry infrastructure that Retrieval has, but you can configure it and execute it in the code. You can basically have a code syntax, create a new Retrieval template, and then pass a code to it, and that code is going to be retried by the Retrieval template. Okay, so here's how it works. You create a new retry template, and then you say retry template dot execute, and then you pass in a lambda. Okay, you can configure the retry template to say, okay, do these many retries, have this kind of a jitter, have this exponential backoff, catch these exceptions and not these exceptions. You can configure it in the retry template, right? Create a retry template, configure it all, and then use that retry template to say execute this, right? You can say a low value payment retry template, retry of 3, right? And then retry low value payment retry template dot execute, tries 3 times. High value payment retry template, and then retry of 10. You take that template and execute, it's going to retry 10 times. Understood? So this is a code way of doing exactly what you already saw without having to put this here. Can you inject it as a bean? Sure, you can. Just an instance. So this is like what I have here is a no-arg constructor. So when you do a no-arg constructor retry template, what you're doing here, you're getting the exact same defaults as the @retrieval. When you just stick an @retrieval on a method, what do you get? You get 3 retries, 1 second delay, and retry on any exception. That's what you're getting over here. But you can configure it in the code. Again, the syntax is not important. You can look up the syntax and know how to pass this in, but remember the concept. You want to run a block of code, retry it, and you don't care about others doing it, you just want to do it here. You basically have a way to move this retry configuration to the caller side rather than the callee side. Okay, when you do an annotation, you're providing the configuration on the thing that needs to be retried. When you use the retry template, the configuration moves to the thing that is invoking, that will need to do a retry. Does that make sense? You're kind of moving the control over to the other side. That's all there is to it. So here's a custom retry policy. You have a retry policy builder using a builder pattern. You can say I want max retries of 5, and then this is the delay, and this is the multiplier, this includes this, and then do a dot build, and you're going to get a new retry policy, and then you can create a retry template with that policy. And guess what? You can dependency inject this policy as well, configure it in one place, and then you can use it wherever you need a certain type of a retry. You can just use that and then invoke it that way. Right? Here are the properties. Again, there is a one-to-one mapping between what you do here in the retry policy builder and what you configure in the annotation. It's exactly the same mechanism. It's basically the style at which you call it is a little different. That's about it. Everything else is exactly the same. Okay, any questions about this? All right, I see thumbs up. And here is the dynamic configuration where you can pass in different values, right? We talked about how configuration is static with the annotation, right? You can use Spring expression language and all that, but still when it's compiled, it is just one value for the method. Here, you see this, it's looking at the order. Looking at the order and saying, is it high value or not? Depending on the value, it's configuring how many retries need to happen. The method executes and it's going to retry. So the same method call, for a high value order, it retries more times. For a low value order, it retries less times. Everything else, the delays change based on the high value or low value. The policy builder takes those computed values, configures it, and then you do a retry for that many times, which is very useful, right? Retry can be defined as a configuration. Yes, you can use all of the Spring parameters, all the Spring infrastructure to get these instances, and you can literally put this in the code like I've shown over here. That's also possible. And this kind of dynamic behavior is impossible with annotations. You can do that with the retry template. When you, okay, this is an important question I want to highlight. When you do the when you're using the retry template, do you still need the annotation? No. No, you don't need the annotation for it. APO still in the picture when using the, what is APO? I'm bad with AOP. Yes, it is. No, it's not. No, I don't think it's AOP. It's retry template has a way of wrapping it itself. You don't have proxies there. The template itself handles the logic. It's similar to, have you folks tried transaction template? It works exactly the same way. So it's basically a class which handles it. You're giving a class a lambda. Okay, let me show you. You see, here is a class, a new retry template, dot execute. You're calling a method and you pass in a lambda. So basically that it has a lambda and it can do things before and after. You don't need a proxy for it, right? It's a separate class. You need a proxy only when you want to hide the fact that it's happening. With the original invocation, with the annotation, you are not calling anything specific to Spring. You're calling the method directly, or you think you're calling the method directly. To kind of keep that illusion of methods calling directly to each other, you create a proxy. It's kind of masquerading as the thing. But here, no masquerade needed, right? It's a separate class where you're giving it a lambda and saying, hey, do this retry. So it does the retry. There's no proxy needed. Transaction template is a thing. Yeah, I read about transaction template, I don't know, maybe like 6-7 years ago, maybe even longer. I haven't used it since, but I'm pretty sure it's there. Transaction annotation has become so popular that no one does transaction template anymore. Yeah, so okay, moving on. Retrying code blocks. This is possible now, right? Retry template.execute. You see here, I'm doing 3 things. Okay, I'm doing a sequence of operations as a unit. If any of that step fails with a retryable exception, the entire block is retried from the beginning, right? So if you're doing this, it's like you put that whole thing in a method, right? Nothing is different, but you need to make sure that they're all idempotent. If validate order passed and charge payment failed, and it is a retryable exception according to the retry template, it's going to validate order again, right? It's going to retry the whole block again. That's something to keep in mind. Okay, So there are some shortcuts like the syntax. Again, you can look up the syntax on the documentation. Pretty straightforward. Once you see it, you know exactly what this does. You have defaults, and then you can configure. Basically, the idea is you give it a piece of code, and then it's going to do as many retries as you configure it. And if you want complete control, you can use the builder pattern. All right. So when to use what? You have the same config every time. You use @retrieval, right? When you want runtime dependent behavior, you want it to change, you use a retry template. Method level retry, you use @retrieval. Code block retry, you use retry template. Right? And usually, like for simple cases where you know that things are consistent, you use @retrieval. And for more complex logic, like the order example that I gave, but depending on a particular value, you're going to have to do different types of retries. You use a retry template. The key thing I want you to remember is that @retrieval happens at the end. What is being retried? The retry template happens where the call happens. So you basically where the retry configuration is held is what matters. After drop off, will you get a recording? Yes, I will be making the edited video available to everyone for free. So yeah, even non-members. So you can watch the recording. I'd love for you folks to stay, but yeah, please feel free to drop off if it's at a prohibitive time, depending on your time zone. I will be sharing the recording later. You don't get to ask me questions though, but you can see the recording. After a long time, I've been around, buddy. I think YouTube is not doing a good job of sending you notifications, so make sure you hit the bell icon. If you think I've been gone and I'm here after a long time, then it's YouTube's fault, not mine. Okay. I'm going to skip testing because I probably want to do another session for this. I'm going to quickly go through these slides. I don't want to cover testing now. There is testing support for it as well. And we have, okay, well, that's about it. We have a different testing infrastructure that I don't want to cover for this session. Do we still need the enable resilient methods if we use a retry template? No, we don't need it. You can try it out. I think you don't need it, but I haven't tried it. You can try it out and see if you really need it. My gut feeling says no, because that's only for enabling the proxies. Retry template has the logic in the class, so it should just work without the enable resilient methods annotation. Okay, so we're going to take another break. 10 minutes, 15 minutes, what do you folks think? Post in the chat, 10 or 15. Those are your options. Don't say 5, okay? I'm a human being. I need a little bit of a break. Okay, I see 2 10s, 2 15s, 3 15s. Okay, 15 is winning. I'm going to go with 15. Also because I'm a little biased towards 15. Okay, thank you. What are we covering after the break? We are going to cover the next item, which is concurrent limit. Right? We looked at retry. We looked at 2 features, right? 2 key features. We looked at retry. There are 2 here, retry and retry template. Now we're going to look at concurrency limit, which is the remaining resilience piece in this new Spring Framework release, right? We're going to cover that after the break. All right, I'm going to do a 15-minute break and then go from there. I'm going to have to edit this again to 15. All right, drop your comments, questions in the chat, and I will address them after the break, and then we can move on to the last piece of this workshop. See you folks in a bit. Hello and welcome back. Hope you had a good break. We are at the final stretch, concurrency limiting, which is the last feature of Spring related to resilience that was released in version 7, and we're going to talk about and try out today. New to your session, absolutely love the presentation. Into which channel can I access the video? Thank you. I see a couple of people have already responded. Yeah, the Java Brains on YouTube, and javabrains.io is my website, so please check it out. I see no questions, so I'm just going to keep going. This is concurrency limiting. We saw retries and everything related to retries conceptually and syntactically. Then we're going to look at concurrency limiting. So retries was about transient failures. When something breaks, try again, right? Dealing with failures after they occur. This section is about preventing a certain type of failure from even happening in the first place. Concurrency limiting is a different resilience pattern, right? Instead of acting on failures, you are controlling how many operations can run simultaneously. You're protecting resources, both your own and external services. The goal is to prevent resources from being overwhelmed at a certain point. We looked at how cascading failures can happen, and overwhelming of resources also cascades, and we want to avoid that. So I'm going to show you how to use the concurrency limit annotation. This is the new annotation that was created, that was added to the Spring Framework 7. And we'll look at the mechanics, we'll understand when it's necessary, and we'll also get into virtual threads. There were a bunch of questions about virtual threads. We'll talk about how it's actually concurrency limit is more important with virtual threads, not less, because one of the things that I saw, like, this wasn't something that was asked for me, but I saw that online in the chatter, which is like, why worry about concurrency limiting when you've got virtual threads? Virtual threads is basically unlimited threads, right? You're not bound by the limited thread pool of the operating system. You can have as many threads as you want. Well, why even bother with concurrency limiting? Well, in fact, it turns out with virtual threads, concurrency limit is more important than, not less, and I will cover why. Okay, what does concurrency limiting actually do? Right? It's a ceiling on parallel execution. When you annotate a method with at concurrency limit and you said, say 10, you're basically telling Spring no more than 10 invocations of this method can be executing at the same time, period. Not more than 10. Okay, this is again for the method that is being annotated, right? You're saying I have a method which is very expensive to run. I don't want more than 10 threads running this method at the same time, no matter where it's being called from. I don't want more than that running at the same time. Right? This is what the annotation looks like. At concurrency limit of the number. We can stick it on top of any annotation. And again, Spring is going to do it magically. Spring is going to automatically set the limit. If 10 invocations are coming in and you have an annotation of 10, it's going to allow. Anything more than that, it does not allow. So it begs the question, what happens to the 11th invocation? The 11th invocation waits. That thread is blocked. Okay, so there is a thread that's going to sit in the thread pool and it's going to wait until one of those 10 complete and the slot frees up. Excuse me. So this is blocking behavior similar to how thread pools or connection pools work, right? So imagine you have a thread pool or you have a connection pool. There is another one that comes in. What happens? It waits until there is a thread available in the thread pool or a connection available in the connection pool. It's basically like that. You're kind of creating this new instance of connection pools or thread pools for certain methods. It's almost like there is a pool available and with a fixed number of slots. So yeah, database connection pools, and you have 10 connections. The 11th one is requested. What does it do? It waits. It waits until the connection is returned to the pool, right? Concurrency limiting applies that same concept to method invocations. So you can think of it as a method invocation pool, a new concept or a new entity that's created called a method invocation pool, and there is a certain number that the framework maintains. Spring implements concurrency limiting using semaphores, right? Because this is a multi-thread operation. There are multiple services that could all be calling at the same time. There's no order, there's race conditions and all that stuff. So Spring implements it in the background using semaphores. It creates n permits. So you have concurrency limit of 10, it creates 10 permits. Permits is a term that's used for this concept in semaphores. So it creates a semaphore with 10 permits. First comes in, it takes a permit and then it's allowed access. Second comes in, it takes a permit, allowed access. If the first is done, it releases the permit and it goes back. But if nothing is done, 10th comes in, gets the permit, it has access. All of them are currently accessing the method. The 11th comes in, no more permit, so it has to wait. That's how it works, right? That's how semaphores work. Here's the execution flow. First, it tries to acquire a permit from the semaphore. If the permit is available, it gets it, executes the method. If no permit is available, it blocks until one becomes available, and when the method completes, success or failure, exception, whatever it is, method completes, it releases the permit, and then the next one picks it up. Right? Very similar to connection pool exhaustion. Right? Caller waits until a resource is available. So each semaphore ensures that no more than n threads can hold permits simultaneously. Right? This has been available in Java for a while. Java concurrency primitives as semaphores. It's just that Spring leverages this using AOP proxies. So again, using AOP proxies. So you don't have to do this. You don't have to create the semaphore yourself. You just have to stick an annotation in. The proxy handles it. The proxy manages these semaphores, and when the request comes in where it doesn't have a permit, it makes it wait. Now here's what it looks like. I have a example code here, which is a report generation service, just a simulation of a method that takes a long time, right? Here is a method that takes a long time, generate report, takes in a report ID and a report type, and then it is some kind of a CPU intensive operation. So you don't want more than 5 of them running at the same time. So you just stick an annotation on top of it. It's a concurrency limit of 5. So no more than 5, right? Simple. In concept, it's very simple. It's the implications where it gets challenging. Like when do you run it? And if you put it, what happens? That's all the things that you need to think about. The syntax in the concept is very simple. Spring manages it. Only 5 run at a time. Concurrency limit. Beyond that, it has to wait. Is the thread blocked during the wait for the permit? Yes, it is blocked. So the caller is like, it's almost like it's waiting, it's processing. Whoever is calling it don't know the difference between whether it is Spring holding on to it or whether it's went to the method and the method is taking time. It doesn't know. All it knows is that it's call and it's waiting for the response. That's how it looks like to the caller, and it's just sitting in the thread pool. It's just waiting. So there is only one parameter for this annotation, which is the value, right? Or just the number in the annotation, which sets the permit count. When you say 5, that means only 5 can execute at the same time. All right? It's very simple annotation, not a lot of configuration as well. It's just one value. I want to address this concurrency versus rate limiting because this came up earlier. Is this the same as rate limiting? It's not. And the distinction is very important. Concurrency limiting and rate limiting are different things, and not just that, they solve different problems. All right, what's the difference? Rate limiting is requests per time. Okay, rate is requests per time. How many requests can happen within a certain time window? Right? Maybe you allow 100 requests per minute, right? the 101st request in that minute gets rejected. When the minute rolls over, the counter resets. Okay, so rate limiting has got nothing to do with what's happening at the time. So imagine every request gets back right away, right? It doesn't take too long, very fast response. Request comes in, instantaneously it gets sent back. But you have a rate limit of 100 requests per minute. The 100th request has gone in, it's returned back, and within that minute, the 101st request goes in, it is not allowed, even if all the resources are free, because you're not looking at what's happening right now. It is in that minute how many requests happen, requests per time period. That's rate limiting. Common rate limiting use cases. Why would you use rate limiting? You want to enforce API quotas, right? You get like 1,000 requests per hour, or you want to prevent abuse. No more than, this is useful for logging attempts, right? No more than 5 login attempts per minute, right? That's to prevent abuse. And often we do rate limiting. I've seen this happen a lot when we are doing third-party APIs, right? We need to interface with third-party APIs. The company has paid money to access their APIs, and they have rate limits. So we're going to set rate limits to make sure that we don't exceed their API quotas. So these are standard use cases for rate limiting. Concurrency limiting is for simultaneous execution. How many at once? And it doesn't cover time period. It doesn't care if it's a minute or an hour. There's no denominator which is a time period. It is how many are concurrently running at the same time. Okay? That's all it cares about. What's executing right now. It doesn't care about time windows. For example, you set a limit of 10. You could, if a concurrency limit is 10, you could process 1,000 requests a minute as long as no more than 10 are executing simultaneously. Let's say each one takes 100 milliseconds. It's really fast. You could have 1,000 requests per minute. It's not rate limited, right? The rate could be anything. It depends on how quickly it returns. The limit only applies to how much is executing at any point concurrently. Is this making sense? This should be clear. I mean, it sounds similar, but they solve very different problems. Okay. Concrete example, payment API constraints. You have 2 constraints. Let's say you have maximum 20 concurrent requests and maximum 1,000 requests per hour, right? The first one is concurrency limit. The second one is rate limit. For the first constraint, you only need to set concurrency limit of 20, right? The max concurrent connections, you set concurrency limit of 20. And for the second one, you would need some kind of rate limiting approach. We don't have Spring 7 does not have rate limiting built in, right? You can use resilience for J, or you can implement your own custom like token bucket logic. So that you either have to use an external library or you have to come up with it yourself. Concurrency limit is what is available in Spring Framework 7. And you can often use both. They're complementary patterns, right? You can use both on the same method, concurrency limit to protect the resource from being overwhelmed, and rate limiting to stay under the throughput quotas, right? They're both possible. All right, so when do you use concurrency limiting? That's the goal for this workshop. That's what Spring has introduced. When do you use it? Right? There are 4 categories of operations where you would need to use concurrency limiting. Technically 3, but well, we'll see. I'll walk you through each of them. What are the different factors? What are the different use cases? First category is when the method is computationally intensive. Okay, some operations are just computationally intensive. So for the report generation example that I gave you, right? Data export, video encoding, large file processing, they all consume significant CPU, significant memory. So if you say, I'm just going to deploy it here and allow all the controllers to access them, well, it can get tricky. It can run out of resources. You can, of course, horizontally scale, but until you get to a point where you're assessing the demand and then horizontally scaling, with whatever resources you have now, you don't want it to be overwhelmed. So you stick in a concurrency limit here, right? CPU intensive operations, category number 1. Category, well, without limits, you have multiple concurrent requests and the CPU is spec'd at 100%. You end up having issues which is a problem, and performance degrades for everyone, right? That's category number one. We want to protect CPU intensive operations. Here's a code example: generate PDF report, stick a concurrency limit in there, and you're good. Okay, and what limit you set depends on your hardware, right? Your operational resource consumption, how much is it actually taking? You monitor the CPU under load and then you adjust, right? The specific number matters less than having some limit, which is better than having none. Category 2 is for external service protection. Okay, many applications integrate with external APIs. You have like payment gateways or notification services. You fetch data from certain providers, and those services might have some capacity limits. They might have their own capacity limits, and you want to adhere to that. They might say, hey, don't send more than 10 at a time, in which case you're going to have to you have to respect their limits, right? Even though your capacity might be more, you want to make sure that whatever you're sending, the gateway you're sending, you don't want to overwhelm. You don't want that to time out. So you would do this. This is the second category, right? With this, you often see a safety margin in place. Like even though, let's say that service can handle 15, you do 10, so that there's a little bit of a safety margin. You set your limit slightly below the absolute maximum, so you get a little bit of breathing room. Category 3 is database connection pooling, right? This is a specific type of resource protection, but it is common enough that I'm going to highlight this separately, right? Think about it, and this was brought up earlier as well. Your database connection pool has a fixed size, maybe 10, maybe 50, whatever. It's finite. So when you're sending requests to it, one of two things will happen. Either your request is within the available capacity for your database connection pool to serve it, in which case it all handles it, or it exceeds, in which case you have a problem. The database gets overwhelmed, and whatever is the failure mode for the database is what the user experiences. So you want to handle it, right? You can handle it using this annotation. Whenever you're making a call to a database, you can prevent pool exhaustion, connection pool exhaustion. It's not about threads anymore. It's not about it's taking a lot of time. It probably takes a lot of time for you to be in a position where you are exhausting the pools. But the point is, you want to make sure that you have a limit here so that that doesn't get exhausted. You're protecting the database, right? Resource protection. That's another reason why you would use this. There's this concept called back pressure. Basically, the idea of back pressure is you're basically signaling to whoever is like, so someone's calling you and you're calling someone else. You can signal back pressure. You can tell that, hey, this is too much. You're pushing too much and I cannot push it forward. So you're kind of signaling it back. So this is a way for you to do back pressure. And you can kind of set concurrency limits along the way across your whole chain so that at every step of the way, the resources aren't exhausted or isn't getting to a point, right? It's saying this operation is connection intensive. Don't start more of them than we have the connections that are available to support. That's what this indicates along the chain. All right, and then category 4, this is file system. This is again, I don't think it is as common with Spring Boot applications. It's mostly database and probably message queues, but this is just another category of resource protection. We have large file uploads, for example, or log processing. You want to make sure that you're not overwhelming the resources, right? I/O saturation is what it's called, limiting concurrent file operations. So again, the common pattern is you're protecting a limited resource. Sometimes it's your own server's CPU, sometimes it's external server's capacity, sometimes it is a fixed connection pool or like a resource that is fixed. So the mechanism is identical though. No matter what you're protecting, you're basically just saying, I just don't want more than n number of them hitting that protected resource at the same time. Right? I'm going to address some questions. Are there any upper limit timeout for thread waiting? Timeouts can be managed, and I suggest you do manage it when you do this connection, concurrent connections, but it is not in the annotation itself. Timeouts are managed separately. So the caller has a timeout, So let's say you have a resource which you want to protect and say no more than 5 at a time, please. You set it to the resource. When the caller is calling, the 6th one that comes in is blocked. Now the caller has to have a timeout and say, okay, I know that you are protected. I'm going to keep sending requests. If any request takes more than 10 seconds to resolve, I'm just going to assume you're overwhelmed and I'm going to time out. So the caller has to set the timeout. The resource under protection declares how many are allowed at a time. The caller decides how long it will wait until it gives up, right? Both can work in tandem. While the threads being allocated, is that it's on hold, how is it preventing wastage of threads? The application will run out of threads here as well. That's a great question. So the obvious problem is, okay, you've protected the resource and you're saying, I don't want more than 5 at a time here. But then of the caller, let's say it's getting requests from the user, right? Let's say it's a controller, right? Caller is getting the request and it is delegating to this. Now this one saying 4 at a time, please, or 5 at a time, please. What is this guy to do? The request coming in all the time, and now this services thread pool is going to get exhausted, right? This microservices thread pool is going to get exhausted. What's going to happen? Well, there are a couple of options there. One is even this can set a limit, and you can kind of push it along the way, all the way up to the user, and the user saying, no, I cannot make a Spring MEC request anymore, but the controller itself fails with an error. That is one option. The second option is using virtual threads. When you're using virtual threads, the thread itself, each thread, as far as Spring is concerned, each thread does not one-to-one map to an operating system thread. Spring maintains its own construct of a thread that it keeps, and whenever a thread needs to execute, that's a virtual thread, right? It's a fake thread that Spring maintains, and it does not put it on an operating system thread. It keeps it in its buffer, the thread object. Whenever there is a thread free and a virtual thread needs to be handled, it takes that object off and manifests it as an actual physical operating system thread. Only then it's consuming the thread. Otherwise, it's waiting. Just put it as a virtual thread and it don't consume the actual resource. That's what virtual threads are, right? I know you've been asking about this as a brief explanation. So if you switch to virtual threads, that's fine. It's not going to take an actual operating system thread. It's going to hold it in an object somewhere. Only when it comes time to execute it, it takes an actual operating system threads and puts it in there. Okay, so that's one way to solve it. But yes, you're right. By protecting a resource here, you're basically moving the burden to the caller, and now the caller has to do something with it. Let's say I have 8 nodes running. How can I control concurrency limits across the nodes? This is not at a node level. This is at a method level. You have a service, and Spring is invoking that service. You have, Spring proxy is invoking the service. Doesn't matter who is calling it. Okay, you have a concurrency limit and say on this service, on the Spring container, there can be only n threads that execute at a time. That's all it's talking about. It's not talking about nodes. It could be multiple microservices from a different place that's getting to those 10. It could be the same service that's calling the method that's resulting in that 10. Doesn't matter. All it cares about is 10 threads. That's it. That's the limit that you set. Again, similar answer. How does it work in a load balance environment? It doesn't care where the request is coming from. It could be load balance. It could be the same service. It doesn't matter. On the Spring container, when the method is being executed, there cannot be more than a number of it. This support of back pressure similar to what Vertex provides? No, this is not a very nuanced. So this doesn't provide back pressure support in that sense. It's basically just a hint. Conceptually, you're giving that back pressure. Remember, I told you if you're protecting this, now the onus is on the caller to do something, right? So it's basically pushing the pressure back. Conceptually, you're doing back pressure, but it's not syntactical, right? Vertex provides syntactical support and a little more support for back pressure. We don't have that in Spring. Would we use this concurrency annotation for managing resources like DB threads and API calling threads, or would it be preferable to use specialized libraries like Hickory or HTTP client thread pooling? You're going to have to use the libraries for connection pooling and thread pooling anyway. This is to make sure that the caller to that isn't blocked. So when you have connection pooling, you don't need this. the connection pool already acts as an implicit limit. You already have thread limits there. Right? You don't need anything else. You don't need this additional annotation. You run out of threads, you run out of threads. There's no more concurrent connections, right? What this is doing is putting it in the code side of things where there isn't an equivalent, right? You don't want to exhaust the thread pool there for you to realize, oh, I don't want to make any connections. Even before the thread pool exhausts, I want to set an artificial limit. That's what this annotation is for. On the database, you don't need an artificial limit. There is a real limit of a connection pool. Okay, does it make sense? So this is basically setting, I want to be a little cautious. I want to make sure that I don't get to a point where you are running out on the database side. All right, let's move on. Okay, the annotation, very simple, just one property. Okay, just a value. How many at once? That's it. That's the simplest that we've seen so far. Right? Here's an example. Some operation takes a while, so you stick an annotation on it. So the challenge is in figuring out what value to put here, and that depends on like your resource availability constraints and all that stuff. So for CPU intensive operations, you're going to look at, okay, how many cores do I have, right? You say I have like 10 cores, so the limit is 10, so that each core is engaged and you don't have like a core doing multitasking and switching between whatever is your situation. You're calling an external service, use the documented limits and set it a little bit lower so that in case they have screwed up, your service doesn't go down. Make it a little conservative. And for IO operations, you usually, like we have file operations, logging, you say 3 to 5 or something like that, a little bit lower. For dynamic configurations, there is a limit string parameter. I'm not going to go into too much detail about it, but this is basically you can use Spring expression language and property placeholders for configuring it dynamically. For different environments, you want different limits, you can configure it using property values. So here's an example, right? So you can say limit string, concurrency limit string equals, and then Spring expression SPL. And this gets evaluated. You can put this value in like an application.properties file or some kind of an external configuration, and then that gets added. So you deploy this application in dev, there is a different concurrency limit. Deploy the same application in prod, there's a different concurrency limit. So this is an additional property, but I would say it is literally the same property. It is just another way to pass in dynamically, but all you're doing is configuring how many at a time. That's all there is to it. Yeah, this is Spring expression language support. You can call methods on beans and all that. So application properties, SPL, they all work with the limit string property. Now, what happens if I set concurrency limit to 1? Suppose I do this. You're basically creating a lock, right? It's not a semaphore anymore. Only one at a time. Only one invocation can execute at a time, right? So this is one way to make something serial. You want something to be serial, execute one at a time, no matter who calls it. You want to make things serial. You don't want to make things, so let's say there is a method that you think is not thread safe, right? Just make concurrency limit to 1. You are guaranteed that only one thread executes that at a time. So remember earlier for the service, what did I do? I had to keep count of how many invocations are happening. I chose atomic integer. Why did I choose atomic integer? Because every request to Spring MVC, which calls this, is a separate thread. Let's say I have 100 requests at a time. This business service, the same instance of the business service is being called hundreds of times. Now, if I have a non-concurrent data structure, you have race conditions and all that. So you assume that when you have a Spring service like this, you assume that it is going to get called with multiple threads. That's the reason why you don't have like instance variables and all that, because you end up with race conditions. Now imagine you have a service which has a race condition. You can do this, right? Concurrency limit of 1, you have a lock. Everything happens serially. Even though you can, I would not recommend it. This is one way you can do it though. So for example, I gave a couple of examples. Rebuilding a search index. When you have like a search infrastructure and you want to rebuild the index, you don't want the index to be rebuilt in parallel because that's going to mess things up, right? That's not a a concurrent operation. If you want to query a large mainframe, that becomes concurrent as well. So you can do this to make it serialized. It's not the same as making it singleton. I want to address this confusion. I know this is a very common question that gets asked, because you think of it as one at a time. The problem is singleton is about something else. Singleton says one instance of a class at a time. Okay, concurrency limit is one invocation of a method at a time. They're very different things. A singleton can be one instance, but a method of a singleton can be called in multiple threads at a time. That can be invoked concurrently, right? I know the path your mind is going in. You think it's one at a time, but I want you to identify that they're two very different concepts. Concurrency limit is like execution. It's basically serialization of invocations. That's what we're talking about. We're making things execute one at a time. So you can, if you want, make concurrency limit of 1 to manage this kind of a lock yourself. Right? Spring handles the synchronization logic through the semaphore mechanism, but be very careful and use it only when it is necessary. I think if you're using it because you have to and there is no way to make this concurrent, then sure, but don't use this as a lazy way to, like, I don't want to make things concurrent, I don't want to use atomic integer, let me make it serial so that I can use regular primitive data types. No, that's not a good idea, right? I wouldn't recommend doing that. All right, so what about the blocking behavior? When all the permits are in use, additional callers block until a permit becomes available. This is the default behavior. There's no timeout, no exception thrown, it just blocks by default. Is synchronizing the method instead of concurrence, it's like synchronizing? Yes, exactly. It's like making it synchronous so that only one executes at a time. And if you think about it, it's actually what the AOP infrastructure is doing, right? It's creating semaphores, and if you have a semaphore of one permit, that's basically a lock, right? You're creating a lock, one goes through, releases the lock, only then the next one comes in. So you're basically leveraging the same mechanisms, but you're doing it in the Spring Boot way. All right, so there are some implications for the blocking behavior, right? This is the blocking behavior. It doesn't time out, it doesn't throw an exception, it just waits. So there are some implications. First is what we talked about earlier, which is that when requests come in and this is it's being used and you are protecting this resource, more requests are coming in, these requests naturally queue up because you're protecting this, but there's nothing protecting the caller. They need to do the job. So new requests coming in and that gets overloaded. And under heavy load, the callers may have to wait for an extended period of time, right? And while that is happening, what's happening over here? This thread pool is getting exhausted, right? These are consuming resources. These are blocked threads that consume resources while they are waiting. You protected this, but now you've thrown this poor service under the bus. Now it has to manage it, right? So we have some options. Since concurrency limit blocks indefinitely, you should have timeouts at the other layers, right? You should have perhaps the HTTP client timeout. You should have maybe a load balancer timeout before it comes here, and then you should have timeouts at the container request layer, right? These external timeouts prevent requests from waiting forever when the system is overloaded. So you have to do that, right? That's the first thing. And you also have to monitor, right? Because blocking is silent. It doesn't manifest anything. So you have to monitor and see how many permits are being fully utilized, and should you increase the response time, indicate concurrency limit might be slow, it might be fast. You're going to have to monitor, and when there is high utilization, you need to alert. So you got to make sure of that. Not just protect it, but also take care of this poor guy or girl who is expected to talk to this protected resource, right? We want to make sure that that service is also handled. So you do that with monitoring and keeping an eye out for how much is actually being used. Are you setting the right values? Should you horizontally scale this thing instead of just blindly protecting it and moving all the problem to the other side, right? Now I want to talk about virtual threads. Okay, before I talk about virtual threads, let's look at the questions. Is the webinar session recorded? Yes, it'll be recorded, and I will make it available on YouTube for free. The stream itself is going to be available, and I'm going to edit this, make it chapters. You know how my videos look. If you haven't, it's basically chapter-wise with a playlist for each course that you can watch in an order. And I'll also make it available on my website. In other words, are you suggesting, can we risk creation of deadlocks with the wrong usage of concurrency limit of 1? Yes, of course. Of course, when you have a lock of 1, you could, even with concurrency limits, you might have a possibility of a deadlock. You just need to make sure that this isn't circular. But with a limit of 1, deadlock is definitely an option, a possibility, but in general, it makes things super slow, right? You build Spring applications for scaling for a large user base. You have like a web controller which is accepting requests. If one thing becomes a bottleneck where you're just allowing one at a time, you're basically completely slowing down the experience for all the users. So you need to be careful about where you set it. Is it common practice to have dedicated thread pools for individual endpoints workflows in a microservice? Yes, it is a common practice. This is what's called the bulkhead pattern. You have bulkhead patterns where you set different thread pools for different services, so that even if one service is slow and it consumes all the thread in that thread pool, the other services can still work, right? There are other services have their own thread pools and they're fine. So only the slow service is blocked from creating new threads. This is a very common pattern, yes. Can I suggest your videos to be shown in schools, or is it feel free to show it anywhere? Just don't download it, show it from YouTube, so that YouTube knows that my videos are being seen. Because if YouTube doesn't know it, it penalizes me and it doesn't show my videos to others. So wherever you want to show it, but make sure you go to the official source. Thank you for sharing. All right. Monitoring is done. Now we're going to talk about virtual threads, because this is important. Spring Framework 7 is designed for Java 21 and beyond, right? And we were looking at Java 25, and virtual threads are a part of that story. And here's the thing about virtual threads. It's kind of changes the whole calculus around concurrency in a lot of very interesting ways, okay? And there is this obvious question that can get asked about, okay, if you have virtual threads, you essentially have unlimited number of threads. You don't need to worry about running out of threads in a thread pool, because every time a thread comes in, a request comes in, you're not creating a new thread as in an operating system thread. You're not consuming resources. You're just keeping track of it virtually. Only when a thread needs to be executed do you pop it off your virtual store and put it on an actual operating system thread. So guess what? You can have thousands of threads waiting, even though your operating system threads are just like maybe 5. They're just waiting. It's slow, but they're waiting there, not consuming operating system threads. Only when it's time for something to execute, it hops on the main operating system thread bus, executes, comes off. So you can have as many threads as you want. So why worry about this? Why worry about concurrent limits? Well, it turns out that virtual threads actually makes concurrent limiting more important and not less. Let me explain why. When you have platform threads, think about it, the traditional model, you typically configure thread pools with fixed sizes, right? So let's say you have a request handler with 200 threads. That pool size implicitly limits concurrency. I talked about like the natural limit, right? So the pool size acts as a natural limit. You cannot have more than 200 concurrent threads because you only have 200 threads. So let's say you have your service connecting to the database. Now your database has 200 connections in the connection pool. You configure your service that calls this database to have 200 threads in the thread pool. Everything's great, right? The 201st doesn't go in, doesn't affect the database. It's exactly tied, exactly matches, which is perfect. Now Imagine what happens when they have virtual threads. You don't have that guarantee anymore. Oh, come on. My clicker isn't working, which is weird. Hang on, let's see. Okay, there we go. So we have an implicit limit that protects downstream resources, right? Even if there are a million requests that simultaneously arrive, only 200 are actually executing because you only have 200 threads. Okay, I have to figure out what's going on here. This isn't working. Weird, it just failed all of a sudden. Okay, now with virtual threads, you don't have that implicit limit anymore, right? They're cheap. You can create millions of threads. Now Spring Boot 4 can automatically use virtual threads. There's a property called Spring Threads virtual.enabled equals true, and then you automatically use virtual threads. So guess what? You have a controller, let's say you have a controller, connects to the database, you have unlimited number of threads. And now there's nothing stopping you from having thousands of threads hit the database. Understood? That's a problem. You have no natural limit. There's no implicit limit. When you get 1 million requests, you're going to get 1 million database queries at a time, and you could potentially run out of connections in the connection pool. Right? The downstream services get impacted. If the downstream service has virtual threads, it's not a problem. Even that can keep it, and it can manage, and it doesn't run out. But at some point, you have a scenario, you have a node which does not support virtual threads. Now you have a problem. It propagates all the way through millions of threads, millions of threads, millions of threads, and this guy has 50 connections. What's it going to do? Right? It's going to have a problem. So you have 1 million virtual threads that needs to make a call to the database. You have only 50 database connections, that's a problem. You have only 20 API connections, that's a problem. You need to have some way of limiting the threads over here, because the automatic limit that you had before with the regular threads, you had an implicit limit with the only available threads in the system. You don't have that anymore with virtual threads. This is unlimited now. Now these gets bombarded. So you need an artificial limit over there. And that's what I meant when I said with virtual threads, there is more of a need for having this concurrency limit, not less. So you need explicit control. Virtual threads are great for scaling, but they remove this accidental protection that you might be relying on. Now you need that explicit concurrency control. So Spring's concurrency limit works identically with virtual or platform threads. You don't have to do anything different. The implementation doesn't care what kind of thread is waiting for a permit. Okay, it's literally the same thing. You use it, and it basically addresses both the virtual and the real thread option. In other words, applications that don't account for it run and break themselves when they upgrade to when you switch to virtual threads, there are a bunch of issues that do come up. It depends on how the threads are allocated. Actually, if you still end up with a one-to-one mapping, like if you still need a thread to be freed up, it forms an kind of like an implicit boundary anyway. But if there are other ways in which you can handle virtual threads, which kind of transfer the load to whoever is calling it. And this was a problem with people who did switch to virtual threads. So it depends on how you use the virtual threads, how often you pop it off and then use it. If it's still a one-to-one mapping. So for example, as long as a virtual thread manifests as a thread, if there is a one-to-one connection with a connection pool, then you're fine. But if you're triggering off something which does work and you pop off the virtual thread while that thing is still working, then you have a problem. Does that make sense? You don't have that implicit thing anymore. So that becomes an issue. So you end up having multiple threads getting popped in, do the work, pass the load on, and then you have the benefit of virtual threads here, so you can offload it, but the other poor guy cannot offload it because that doesn't have virtual threads. Then it becomes a problem, right? So it depends on how you use it. Virtual threads aren't executed anyway. It'll be on hold until a natural thread is... Yes, literally what I explained. So if there is a one-to-one mapping, right? If you know that when a virtual thread manifests as a physical thread and only then you're causing something else to happen there, then it is fine. But if you pop in a virtual thread to a physical thread, trigger off a work, and now there is work there, and you have some kind of a mechanism to pop it back off, then you're offloading the work here while piling on the work over there, which becomes a problem. What or would we need compliant DB clients like we do for reactive flows? Yeah, I'm not aware of that actually. I don't have experience with that. I am aware that there are certain configurations and clients you do for reactive to make that reactive as well. That could be one approach. I don't have much knowledge about it, so I don't want to comment on something that I don't have experience with. You can try it out if it works. Maybe there are advancements to how database threads are handled with the virtual threads as the established technology. Yeah, that's something for me to research. I'll find that out after this. What are the drawbacks of virtual thread usage? For which kind of operations is it worth option as a regular one? If you have virtual threads all along, then it's a great option, right? You're not limited by physical threads anymore. You have one service calling virtual thread, another service which is also a virtual thread. So it's basically like you don't have the thread limit at all anywhere, right? You basically remove a thread when it's not being used, pop it back on. So theoretically, you have unlimited threads. The unfortunate fact is at some point in real enterprise systems, at some point, it does end up hitting a system which does not have the luxury of just popping it off wherever it wants, right? The database connections is one example. But if you don't have that, or up to that point, if you want to manage extra load, you can use virtual threads for it. That would be the benefit of it. Virtual threads are not good for CPU intensive tasks. They're good only actually made use for IO calls. Yeah, yes. If you're using CPU intensive, that means that you don't have the ability to offload the virtual thread. You need an actual physical thread for it. So you don't get the benefit of the virtualness of the thread. Virtual threads only apply with all these kind of things, right? Even with reactive programming, it only applies when you have a thread that's waiting. It doesn't need to use an operating system thread. That's the whole point. When a thread isn't doing a job, it's just waiting. Why hold on to an operating system thread? Why not park it to the side? That's what reactive programming is doing. That's what virtual threads are doing. But if it is actually using CPU, it needs a physical thread, and there's no benefit to virtual threads per se. This all makes sense in one code base. How does it work in the case of microservices? It's exactly the same with microservices. Again, with concurrency limiting, it doesn't matter where the request is coming from. Is it coming from an external service, or is it coming from another controller or another Spring component in the same service? It doesn't matter. It's limiting the amount of parallel things that can happen on this method. It doesn't matter where the request is coming from. All right, let's move on. Okay, this is an example. I don't know why I put this slide. It's concurrency limit of 20, so it's just 20. It doesn't matter if it's virtual or physical threads. It's still the best concurrency limit. So you get the best of both worlds, right? This is what you want. You get the scalability of virtual threads for IO-bound operations, which is what we need virtual threads for, while still protecting resources which cannot handle unlimited concurrency. So you get a bit of both. Now, what are some best practices with virtual threads? With what you need to limit, right? We talked about this a little bit. I'm just going to reiterate that again. When you have external API calls, almost always they have concurrency limits. Even if it's not documented, they're just going to break if you go beyond a certain point. So you need to make sure that you don't cross that limit. You won't know for sure whether you're going to cross it or not when you code. So you establish that there in case your app becomes viral, super hit at some point, it's still not going to break. It's a safety mechanism. And database operations that hold connection pools for an extended period of time, right? And you have a virtual thread here, you start a job and then you hop off, bring another thing in, start a job. Well, you have a problem where you have to limit it. And CPU intensive operations where virtual threads don't add CPU cores. You basically have you need to map to number of operations at a time should map to number of CPU cores that you have. It's a good practice, or at least do the calculation, make sure that you're not overwhelming CPU. And file system operations, IO contention is a concern, so you would use that. You don't want to limit fast operations, right? Simple IO operations that you release resources quickly, like typical database queries which execute in milliseconds. Virtual threads handle these very well, and you don't need explicit limits, right? So virtual threads remove the need for thread pool tuning in most places, but they increase the need for resource protection when the resources are genuinely limited. So you have to just run tests and make sure that you're not overwhelming in various different load scenarios. All right, and you can combine these patterns, combine these two patterns. What are the two patterns we learned today? Concurrency limiting and retries. You can actually combine them both. They solve different problems, but they work well, right? So you get complementary protection with concurrency limit and retriable. So here's an example. Here is a process payment. Let's say this takes a little time to execute, and it's also retriable. So you set a concurrency limit on it, and you make it retriable. So you basically get both, right? It's protected by both patterns. Concurrency limit ensures that no more than 15 here process simultaneously. The retry logic handles transient failure, so you're trying up to 3 times with exponential backoffs, and the retry honors the concurrency limit. So for example, you try once and concurrency limit hasn't been hit, so it executes, it throws an exception, goes back, waits for a minute, and waits for 1 second. The next second it tries to run, the concurrency limit has been hit. Well, guess what? It waits, right? So it both works together, so you don't have to worry about okay, what happens if I retry and this is already, Spring is going to handle it, right? It's going to do the right thing, so you don't have to worry about it. And the order of execution matters for this. This is the AOP proxy layering, right? So you have the concurrency limit is checked first, the permit is acquired, the retry logic wraps the actual method, the inner proxy. I think I told it the other way. It's one of these two. I think we can figure this out with a test, whether the concurrency limit happens first and then the retry happens, or the retry first and then the concurrency limit is checked. One of these two happens, and when the method completes, the permit is released, right? Don't go by what this says here. I haven't fully tested this out, so this is one part that I'm not very confident about, so you can do your tests and figure this out. I think I tested this out with multiple retries, but I don't remember, so I'm not super confident, right? Okay, so when do you combine both? When you need to limit capacity, resources limited in capacity, and it also occasionally fails transiently, right? So external APIs fit both criteria, right? They have concurrency limits and they do tend to fail occasionally. So that's a great example for doing both of these. All right, I have a realistic example here, check inventory, which has both retriable and concurrency limit. I'm not sure what I was going for with this slide. I have my notes here which says that the retry tries with one concurrency. One operation holds one concurrency permit. So the retry is holding on to one concurrency permit. That could be wrong, but you might want to validate that. Okay, what not to combine? Don't use concurrency limits for operations that are naturally serialized by other means, right? You don't want to do concurrency limit of 1. For example, When you want transactions, use transactional. With pessimistic locking, don't use concurrency limit because the database is already serializing access, right? That's already a serialized operation. Use transactions to control database updates. Don't use concurrency limit of 1 because one, you basically add more complexity, and secondly, you make things slow. You want the database connection pool to handle that, and the database primitives to handle whether those two are in contention, whether two operations can run in parallel. Let the DB handle it. Don't serialize it ahead of time unnecessarily. And when you have operations that must complete immediately, you have to be careful about what you retry and how many concurrent limits you have. And you want this to happen very fast. You know that the operations happen fast. Don't just set crazy concurrency limits for it, right? Instead, if you really want, you want to scale horizontally and optimize the operation itself. And again, monitoring, tuning, and testing. That's the way to do it. Monitor concurrent connection executions, wait times, how long is something waiting, how long does an operation take to complete, which could potentially include the retry time as well. Look at the latency and figure that out. This is where Spring Boot actuator metrics really helps. If you have actuator, you can figure this out, or if you have any other ways in which you can track the metrics, you can figure this out as well. All right, I'm going to skip this. And you can tune for different environments. I talked about the limit string property. You can use that for setting different values for dev versus test versus prod, and you can configure that as well. All right, let's see if I can, I'm going to skip past the test. All right, now we're going to move on to the hands-on exercise, the last piece before we wrap up, which is the report generation service. Okay, so let's switch over to the hands-on. This should be super quick. This is a very small exercise, and you will know it when you see it. I'm going to switch to IntelliJ. This is the second in the exercise. I didn't want to put it together, even though it's very simple. I have two. So this is Spring 7 Workshop 2 folder in the start directory. You should see, okay, you should see a simple controller. Here is the Spring main class. It's a very simple controller called /report, which is making a call to a generate report method. And this is a slow, long running task. Okay, you have the value, it's just sleeping to simulate the slowness. And when you run it, you can basically hammer it with a bunch of curls and it's just going to take longer and longer and longer, but you can limit it. You can say, I want only a couple to run at the same time. So in that case, it optimizes how many run together. I'm just going to execute this. This is the before. I'll show you how it works. You can try this out yourself. Okay, I'm going to have to stop the other service. Hang on a second. This is workshop 1. This guy, stop this. And I'm going to go to this guy. Okay. Now you have me run this application. And I'm going to go to the controller. I'm just going to curl here, right? So generate HTTP. This is the value. I'm just going to go to terminal and I'm going to curl. Okay, so I'm going to say curl and stick an ampersand at the end so that it runs in the background. And then see, it's doing its job and it waits for a while and it returns. Okay, so I do one, wait for 2 seconds, and I do another, It is also starting. Each one is taking its own thread. The first one returns, and after 2 seconds, the second one returns, right? Okay, there it returns. So it's basically taking in as many as you do. There's no concurrency limit at all, okay? Now, if you switch to the concurrency limit part, again, go ahead and quickly add that code so that you practice writing it. It should be very simple. Basically, what we have here is this one line, concurrency limit of 2. I've set it as 2, okay? You can set it as how much ever you want. It is going to limit the concurrency to as many as you have over here. So let me run this. And now it is only going to let 2 at a time. Okay, so I do a curl, and then I'm going to run the report with the ampersand. I'm going to run 3 together, okay, 3 in quick succession. What happens is it'll return the first 2 immediately. The third one is going to wait. The third one is not going to return immediately. Then it's waiting for the 2 to clear, and then the third one is going to get picked and it'll return. I'll show you what I mean. So I'm going to run 1, I'm going to run 2, I'm going to run 3. Okay, 3 are run together. Now 2 are executing at a time because I have concurrency limit of 2, and 2 will return immediately. See, 2 return immediately. Now the third one is getting picked. The third one still hasn't returned yet. After a while, the third one will return, and then you will see the response. See, now the third one returned. All right, that's concurrency limit. So the 2 went in through because Spring let in. The third one took a while because it was waiting for the 2 to return. Only when the first one returned, the third one was able to go in. Okay, that's the result. All right, so that is concurrency limit. Any questions? Let's look at questions here. Is this the proper way to think? We are yet to have databases that support virtual threads as well as they currently support in platform thread pool sizes. I wouldn't say we are yet to see them have virtual threads, because the thing with the database limitation is more connection pool than processing. Okay, so you have connection pooling, and usually databases set connection pools so that forms the limiting factor before the CPU gets overwhelmed. You can set how many connections you want to allow in the database. More powerful database server, you allow more connections in the pool. Less powerful, you allow less connections. So you want to set that as a limiting factor before you end up overwhelming the server. Remember, virtual threads are useful when the thread is waiting. When all the threads are CPU bound, there's no benefit to virtual threads. And with databases, when it comes to the database, it is often CPU bound. The database usually doesn't wait. It gets a job, it's actively working on it, and then it returns back. So I don't think there will be an equivalent of virtual threads in the database, because all of database is IO bound and CPU bound. So that forms the limiting factor. Okay, so you have 2 different paradigms. You just need to implement that kind of a protection so that you don't get that overwhelm of resources on the database side. All right, let's look at the next questions. Do we get any testing support? Yes, there is testing support. I might make another workshop about it. I don't want to extend beyond what we've already covered. I see we are at time. So I will cover testing as a separate workshop if you folks are interested. Well, I'll post that there. If you folks are interested, register. And if I have enough people registering, I'll create the workshop. Is it live or recorded? This is very much live, my friend. This is your proof. This is live. It is recorded, and I will make it available in the future. It will be available online. Virtual threads are also like thread pools. No, they're not. I've covered it a little bit in this workshop, so please rewind or watch it again, and you should be able to understand the difference. How do I find time? I just somehow manage. I usually say I don't have a life. I don't watch movies and all that stuff. And I like teaching. I like teaching you guys. So that's how I find time. The highlight the console for Git is from IDEA. No, it's not IDEA. It's a ZSH theme that I set up. You get plenty of those online. Just install some. I think it's OMI ZSH is what it's called. I use that. OMZ, yes, that's the one. OMI ZSH. I think I configured that in a live stream. Must be there somewhere. So if you're interested enough, you can go take a look. I don't think it's worth the effort. So just go to OMI ZSH and you will have a lot of themes as well as instructions for how to configure and customize it. All right, so with that, I'm going to wrap up this session. I have a request from you. I have two requests from you. First of all, please revisit this video and kind of visit the points that you're not very sure about or you were confused. Just go watch them again so that you cement the ideas in your head, and also try them out. Try out all these different things. One open question that's still on my mind that I want to try out is, what comes first in the order? Does retry come first or concurrency limit comes first? Does a concurrency limit allow an invocation and then the retry does multiple retries? In which case, even if so, a retry is waiting, it's blocking a concurrency, or is it the other way around? A retry checks each time for each retry, does it need to get a permit? That's something to try out. So I recommend you try out and play around with those things. I certainly will. And secondly, please share this on social media and recommend. YouTube has not been doing such a good job of spreading the word. A lot of people come and ask me, hey, are you still making videos? And I go, yes, you just don't get notified because YouTube used to notify based on I don't know, whatever parameters. Now it's more notifying. It's more biased towards clickbaity and more like entertainment stuff, because I think that's what makes more money for YouTube. Educational stuff, it kind of prioritizes low. So that's why I would request you folks to share this. I'm going to publish the edited video as well. Please watch that and share it as well so that more people are aware that this exists. It's I don't think I can rely on the YouTube algorithm anymore for this stuff. All right. So with that, thank you all for joining, and if you're having holidays, happy holidays, and see you folks in the next live stream.